Hello and welcome to FME Desktop for Databases. So if you haven't started your virtual machine already, please go to the URL there and start it up. These machines do take about 10 minutes to start, so if you haven't done so already, it's best to get it going now so you don't have to miss any of the exercises later on. This is the same link that was sent out in the email, so if you already did it yesterday or this morning, don't worry about it. All right, now so for some introductions, my name is Tia McKillop and I am an FME Desktop expert here at Safe Software. And with me today I have Mark Stokes.
Good morning.
Once again, here is the URL if you haven't got it yet. We will be using these machines for the training course, so unless you want to just sit back and watch, you do need one of these machines to participate. We'll be covering some select articles from our database tutorials available on our Knowledge Center. This is the link for the course materials. I'll just get Mark to send out the link as well to you guys. So we'll just be going through select articles and following along. These articles are primarily geared towards Oracle. So for the training course today and tomorrow, we'll be looking at using Oracle. If you use another database, that's all right. Most of this stuff is transferable between Postgres and SQL Server as well. I should mention that those materials are available after class if you do need to go back and catch up on anything. We'll be connecting to an Oracle database. The connection parameters are listed here, but I'll go through them with you guys later on when we look at actually connecting to the database through FME. These credentials are also posted on our training resources page as well. So we're going to cover working with FME and databases, Oracle in this instance. So we're going to look at how to connect to the database, how to read Oracle data, how to write to Oracle, some incremental updates, as well as looking at FME database transformers, such as the FeatureReader, SQLExecutor, and FeatureWriter. If you find that you're really comfortable with this material and you want some further database education from us, we are offering a webinar at the end of the month. It's called Let the Database Do the Work, and myself and another colleague will be presenting that. And you can sign up online at safe.com/webinars. And this is going to be focused on how to get FME and your database working more performant. So quicker reads and writing with constraints or foreign keys, as well as using triggers or sequences. Today we'll start with our Getting Started with Oracle tutorial series, where we're going to connect to the database, view and inspect data, read from Oracle, and write to Oracle. As well as we're going to look at using the FME DB operation to perform some updates on the database. All right. So, like I mentioned, this is our course resource page. So it's called Mastering Spatial Databases. If you haven't been able to follow the link, you could just go to knowledge.safe.com and search for this title here. Also on this article, there is yet another link to your virtual machine if you haven't set that up yet. We'll be using Amazon AWS EC2 virtual machines for the exercises today and tomorrow. Each virtual machine contains an installation of FME Desktop and FME Server 2017.1, as well as an Oracle database preloaded with the sample data you need. The remainder of the data will have you download from articles, and I'll ask Mark to message them out as we go along. You'll be using the same virtual machine tomorrow, so you don't need to log off or shut down the instance. You can just close it up top here, so just hit the X, and you'll find that the machine tomorrow will run faster. So the longer these machines are awake or alive, the faster you're going to find that they run. All right, so we'll just start off with our Getting Started with Oracle tutorial. This tutorial series will focus on how to move data into and out of the Oracle database, as well as introduce some new key concepts, as well as the Oracle Reader and Writer that FME offers. FME provides support for both spatial and non-spatial data with Oracle Spatial Reader Writer or the Oracle Non-Spatial Reader Writer. For this training course, at least for today, we'll primarily be using the Oracle Spatial format, just because a lot of the tables and data we'll be using are spatial. Some database terminology before we get started. Schema is also known as the data model. In the Oracle table list, the table name is prefaced by the schema. So you're going to see it as schema.table. Coordinate system is also known as the spatial reference system or spatial reference identifier, so the SRID. Before you can begin working with the Oracle database in FME, you must have the Oracle client or Oracle Instant Client installed. If your Oracle format is missing or grayed out or unavailable to use, this likely means that you're missing the Oracle client or that your Oracle client is not the same bit version as FME. So 32-bit FME does require the 32-bit Oracle client, and the 64-bit requires the 64-bit Oracle client. We've set this all up for you, but if you want to use FME and Oracle in your own environment, please ensure that you do have the Instant Client installed and it is the matching bit version. We have an article here that goes through how to set all of this up, whether you're using Windows, Linux, or Mac, and it just gives you further instructions on how to get that Instant Client set up and readable by FME. All right, so we'll move on to viewing and inspecting Oracle data. Connecting to a database differs slightly from selecting a file or folder-based format. Establishing the connection requires that the database connection parameters be supplied. Basic database connection parameters are host or server name, network port number, database or service name, username, and password. These parameters are going to vary depending on the database format being used, but FME will always prompt you for the ones that you need. For example, with Oracle, we're going to prompt you for the service name or easy connect string, as well as the username and password. For another database such as Postgres, we're going to ask you for all 5 of these. All right, so let's get started using FME. I'm going to just do a split screen here, just so I can have the article open while I'm going through this with you. And we'll just start off by opening the FME Data Inspector. So just the icon down here with the magnifying glass. Your virtual machines might be a bit slower than mine just because I've had mine up for a couple days already now. And we're going to add a data set to our view here. So just go File, Open Data Set. And we will be connecting to Oracle Spatial. So if it's not already there, just go ahead and start typing in Oracle. And we'll see Oracle Spatial Object come up. And here we're going to define our data set. So there's 2 options to connect to the database through this parameter here. The first is being embed connection parameters, and the second is add database connection. Embed connection requires the user to enter connection parameters each time you read from or write to the database. While the add database connection or named connection provides a simple and secure way to store and reuse the database connection. So once the parameters are specified here, we're going to save and store them so you can reuse them over and over again in multiple workflows. So if you are using a database connection multiple times, it is best to use this add database connection or named database connection, just so you don't have to enter the parameters every time you need it. So we'll be using this one for the exercise today, so we don't have to enter our connection each time we want to read from or write to Oracle. And now you'll see here that FME is prompting me for the parameters I need. Had we chose embed connection, I'll just pull it up now, but you guys don't need to. You'll notice that FME is not asking us for a name. This is because we're not actually storing this connection outside of this one instance. So that's why we're going to just keep using the add database connection, so we can provide a meaningful name to keep it simply secured and stored for us. So if you just want to go ahead and name it Oracle Training Database. The service name or Easy Connect is just going to be localhost, and our username and password is FME, all capital. It's a good idea to test the connection to make sure you're able to successfully connect to the database before saving the connection. You can also connect using a TNS names file. This is a tnsnames.ora file, and it can reside anywhere on your system, and FME can read this as well. You do need to set this up. There's additional configurations for this one, so you do need to set it up in your TNS admin environment variable path. We won't be using TNS names in the exercises today, but should you want to use this on your own machines, there are instructions here in this viewing and inspecting Oracle data training article. All right, so once we've established our successful connection to the database, we can go ahead and save the connection. And now we'll have to go into the parameters and pick what we actually want to read from the database. If you're reading from the default Oracle workspace, which is live, you can just go ahead and leave this blank. But if you are reading from a different one, you're able to pick it through here. We're just using the default one, so we can go ahead and leave that as is. But it's the table list that we need to fill in. And we're going to be reading from the fire hall tables. So there are a couple ways. You can just select it here, but if you do have a lot of tables, you can filter. So you can filter by table name, as well as schema, which isn't particularly useful in this case since we only have the one schema, FME. But if you had a lot of schemas or a lot of tables, it's a quick way to filter through them all instead of collapsing the schemas or scrolling through. So just go ahead and select fire halls. And we'll see here in our selected items that we have the schema, which is FME.firehalls, our table name. And we can just select OK. And one more time. And now we'll see that we've read in our Oracle table, so FME fire halls, and we have all the various attributes below, as well as the point data. So we've got our fire hall names, our address, as well as some equipment details here. I'll point out here in the FME Data Inspector, but this also exists in Workbench. You can go to Tools, FME Options, Database Connections, and here you can add or remove connections. So had you misspelled Oracle Training Base and you wanted to remove it and re-add it to get that properly spelled, or just want to add more connections here, you can just hit the plus sign. See, there's the 5 parameters that I mentioned Postgres has, and you can just go to Oracle and type them in here and save them here. You'll notice by the default, the only option here is to actually create a database connection, a named one. So you cannot create an embed connection here. This is where you're going to create connections that are going to be stored in FME. Okay. All right, so we'll move on to the second exercise now. I've heard that some of you aren't able to see the fire halls tables. That is all right. We're just viewing it for this one, so if you have to use a different table, that's okay. I'm not quite sure what happened there. That table should have been preloaded into your database. But we'll move on, and if any other tables are missing as we go through, we'll just adapt. So let's just close the data inspector. And now we'll look at how to convert from Oracle. So we're going to be reading from Oracle in this exercise. So these articles are available offline, like I mentioned. Some of them do have a video. The videos were filmed using 2016.1. We're using 2017.1. So if you do want to play catch up later on, or you have to step out, you can watch these videos. The procedure is very similar between 2016.1 and 2017.1. FME might just look slightly different. You can also export these to PDF if you want to print them for use later on. There are a number of parameters that can help provide control when reading from a spatial database. So that we've listed them here in the article. I prefer if we add them to FME so we can actually see where they all are as we go. So I'll just do my split screen again. And this time we'll open up Workbench. So we're going to add an Oracle Spatial Object Reader. So new to 2017.1, we can type on the canvas as we would with a transformer to add a reader. So we'll select Oracle Spatial Object. And we'll use our training connection, or Oracle training database connection that we've set up before. Once again, if this format doesn't come pre-populated with Oracle for you, you can just type in Oracle Spatial Object, and we'll use the training database. Now when we go into parameters, in our table list, we're going to be reading the parks table. And we'll just add that onto the canvas. So if your table list was a bit slower than mine, no worries. I'm not going to go much further here. I'll just discuss the parameters. So just add the FME.parks table. It looks like the parks table might be missing as well. So I'm just going to go through the parameters in the meantime while Mark takes a closer look at this. So just let's look through the reader parameters that I had mentioned previously. So you are able to set a where clause in the navigator. And this where clause is equivalent to sending an SQL where clause to the database. So you can type something here where you can set where whichever attribute name equals a certain value. So this is going to do a select star from table where, and then this is the query that FME is going to send to the database. And this is going to limit the number of rows you're reading in. So if you can limit the number of rows or features you're reading in, you're going to find that you have a quicker read, and your workflows will perform a lot faster. There's also a search envelope. So here you can define a minimum bounding box using the min xy and max xy. It's going to be a lot faster if you set this search envelope to spatially minimize or restrict the amount of data you're reading in. It'll be faster than reading it all in and then using a clipper to clip on this rectangle. The caveat being here is that your spatial table does need a spatial index in order for FME to perform this spatial query. You can also set a search envelope coordinate system, and this can be different than the one that you've set on your reader. So you can read in lat long, and if you wanted to use a UTM coordinates to perform the search envelope, you can go ahead and do that. Just make sure to set it as such. There's also the option to clip to search envelope, and this will be faster than reading everything in and using a clipper as well. The envelope here is a rectangle, so if you do need a shape other than that, you might need to use a clipper. And reading in all of the data and without clipping, of course, will be faster than reading and clipping. We also have the features to read. So you can set the max number of features to read. You can also set them per feature type. So what per feature type means is if you're reading in multiple tables using the one reader, you can go ahead and select how many features you want to read per table. These two parameters are really useful if you're editing your workflow or testing or trying to get a translation going, and you don't want to read in millions and millions of features in order just to test to make sure something's working. You can set the max number to say 5,000, and you're going to find that you're able to quickly test and make sure that your workflows are running as expected before sending the whole suite of data in. And lastly, there is a FeatureReader Transformer. Which has some of these parameters that I mentioned. I won't go too much into this because Mark will be covering it tomorrow, but it is another option you have when you're trying to get a faster read. If you do think this stuff is quite interesting, please check out our webinar at the end of the month because we're going to go through more details on how to read from your database with FME more efficiently. Okay. Okay, so I hear you don't have parks, but if we do have the countries table, we can use that one for the time being. So I'll just go ahead and delete my parks. And I'll re-add my reader, so Oracle Spatial Object, the training database. And if you have V country CA, you can add that. And we'll just use the exercise doing this one instead of the parks. So let's just go ahead and inspect this. It's always a good practice to inspect the data to see what you're actually reading in, especially in this time when we have to change the table. So we'll just load the data set. It is quite a large one. So we see that we have point data here. We have some city names by the looks of it, as well as Latin long. We got some feature class information, country code, which I'm going to assume is all CA since this is Canada, as well as this time zone attribute. So we have America/Vancouver, America/Toronto, Regina, Edmonton, Halifax. So quite a few there. So since this is such a large data set, we're going to limit what we're reading in using a where clause, and we're going to use this where clause on our time zone attribute here. So we're going to limit everything into where time zone America/Vancouver, since that's where Mark and I are currently located. So I'll just go ahead and minimize this. So in the navigator, expand that again, under our parameters, we can set this where clause. We double click, we're going to set our where clause to, so we're going to use double quotations. It's time zone, so this is our attribute name, equals, oops, double quotes. And then we're going to fill in our attribute value, which was America/Vancouver. Just going to make sure I have my slash the right way. Okay. And what this is going to do is this is going to send this where clause to the database from our reader here, and we're only going to read in where the time zone is America/Vancouver. So hit OK. I'm just going to connect an inspector here to make sure that this is working as expected. Oops, that's a logger. And I'll just give this a quick run. So that looks like BC to me. And we'll see here now that our time zone is just America/Vancouver. There are a lot of points though. So we've limited in the points we're reading from Oracle just to the 1400 that have the time zone that we've set in our where clause. We're going to write this out to file geodatabase. So we can add our writer. We're using the Open API version since we don't need an Esri license for this one. And select the writer. And we just have to select a location to save it. So I'm going to save it under Administrator, Documents, and we'll just call this America/Vancouver. We can leave our feature class or table definition as copy from reader. So we'll add that to the canvas, and then we'll open it up and double check the parameters. And we'll see that FME is prompting us for the geometry. Since we've inspected, we know that these are point features. And I'm going to give this a more useful name than what we have it stored in Oracle. So I'll just call it America/Vancouver again. We can go ahead and connect our reader to our writer. And it looks like our attributes match up pretty well. So let's just go ahead and run the translation. We can inspect our output to make sure it's written successfully. And here we are. We have our file geodatabase, the 1400 features. Our point data looks good. And our time zone is America/Vancouver. So this is a great way to limit the number of features you're reading in. We can also use concatenated publish parameters to help limit the features we're reading in and provide a way to prompt the end user with an option to set a new where clause. So if we didn't want our end user or ourselves to keep having to go into this where clause and editing it here, we can make use of published parameters to prompt us when we're running to change what time zone we're reading in from. So we can do this by right-clicking on the user parameter here and selecting Create User Parameter. We can leave the type as text. We'll set the name to time zone, since this is what we are selecting on our where clause, and we can set the prompt to time zone as well. We can specify a default value here if we wanted to, or we could leave it blank. I'll specify mine. Just make sure you are using single quotes. And I've just set mine to America/Halifax. So now that we see we have this published parameter called time zone here with our default value. Next, we're going to right-click on our where clause and create a user parameter here. We're going to uncheck publish to keep it private. So this is something that we don't want the end user to see. We don't want them to see our prompt for the where clause. Instead, we're just going to prompt them for the time zone parameter that we've created. We can edit it here, or by clicking the ellipses button here. This is a foolproof way of editing it. We can just go ahead and delete what we've set there and add our time zone parameter. So what this is doing is sending whatever time zone the user enters in the published parameter we're prompting them for into this where clause, which is going to be sent to the database to help limit the number of features we're reading in. And we can just hit OK until we're out of here. Now if we turn run with prompt on, and hit play, we're going to see that we're prompted for our time zone. I have my default value here, which is America/Halifax. I'm going to change it to America/Regina and hit OK. And now FME is going to send that as our where clause to the database. We can inspect our file geodatabase. So now we'll see here, since I've just inserted the records, we still have our Vancouver time zone here, but we also have Regina. So for those of you who aren't familiar, that is Saskatchewan over there. And now if we look at our time zone, we'll see that we also have America Regina as well as America Vancouver. If you wanted, when you're running the translation, instead of having the user having to manually type this in, we can use a choice option for our parameter. So if we go ahead and edit the definition of this, I'll just go through this quickly so you don't need to follow along. We do have a type here of choice or choice with alias if you want to hide those single quotes. So if I did choice, I can configure this So I'll just do those three there. So now when we run, instead of having to manually type these in, I can just select which time zone I want to put in my where clause. Okay. We're going to move on to the next exercise. So we're just going to go through another exercise, and then after that we're going to practice loading data into Oracle from Postgres. So we do have a Postgres training database that should be available to you all, and we'll just load the tables that we need for the remainder exercises from that database into our Oracle one. So before we do that, let's just do one more exercise together. And this one is converting to Oracle, create, drop, or truncate a table. This one we are downloading the CSV data from on the article. So when Mark gets a sec, he'll just message out the link here. And you could just go ahead and download it. You can leave it in the downloads bar below. While Mark's getting that link sent out to you, I'll just talk a bit about feature operation and table handling. So on your writer feature type, you can set the feature operation or table handling. Our feature operation here is applied to the whole table, and they are insert, update, or delete. Insert means records will be added or appended to the table. So we saw that in the previous exercise with our file geodatabase that our different time zones were added to the database. Update means records will not be inserted or deleted, but rather replaced. And delete means that records will be deleted from the database. For update and delete, FME will want you to specify a key ID or a match key. And what this does is FME will look for this attribute with that particular value and check to see if it's in the database, and that way it'll know whether to perform the update or delete. We'll be using the FME DB operation later today, but this is an attribute where you can set this insert, update, or delete values onto it, and then you can specify which operation on a per feature level. Some table handling parameters are use existing, which you're going to use the existing table when you're writing. Create if needed. If no table currently exists, one will be created. Otherwise, we will use the existing one. Drop and create. This is going to drop the destination table and recreate it. So this is useful if you've created a table and you just happen to be missing an attribute or a column, and you want to drop the table and recreate it. Truncate existing deletes all rows or features from the table, but does not delete the table itself. So any constraints you have on the table will still be there. All right, so hopefully you've downloaded the CSV file from the top here, downtown.csv. And we can just go ahead and drag and drop this onto the canvas. So you'll see here that FME knows it's a CSV file because of the extension .csv. Don't hit OK yet. We're going to go into the parameters. So you'll see we have a nice little preview of the data here. It looks like we have a name of the location as well as title. So what we're looking at here is art features in Vancouver, as well as we have Latin long coordinates. So we're going to tell FME to create points from these Latin longs. So we're going to go down to the attribute definition here and select manual. And we'll set our longitude to X and our latitude to Y. So we've just gone manual and set longitude to X and latitude to Y. We'll select OK. And before we add the reader onto the canvas, we're going to set our coordinate system. So now that we've told FME we have points, we're going to tell what coordinate system they are in. And they're in lat long 84, LL84. All right. I'll maximize this now that I'm done grabbing the data from the article there. And we'll just inspect this to make sure it looks as expected. All right, so we have our point data here. So had we not set the coordinates as X and Y and didn't give it a projection, we wouldn't have point data. It would just be a table here with no geometry. I just noticed I have multiple views open in the data inspectors. If you have them as well, you can go ahead and close them. It's going to be all those points from that country data, so we just want to close that to not overload our data inspector. Now we're going to write to Oracle, so we'll add an Oracle Spatial Object Writer. We're going to write to our Oracle training database. We can leave this as copy from reader as well. So first things first, we have defaulted to naming it CSV. This isn't a particularly useful table name when we're writing to a database, so let's change it. We can call it Downtown Public Art. You'll notice that FME has capitalized it since Oracle does prefer its table names to be capitals, and our table qualifier is FME. So I'll hit OK. Now we'll see we have our schema.tableName. If we go back into our feature type properties, we'll see that the feature operation and table handling can be set here. So we have insert, update, delete, and FME DB operation, as well as the table handling. We'll just leave those as insert and create if needed, since we don't currently have a downtown public art table in our database. And we'll select OK. We can go ahead and connect the two. Now we'll see when we expand the feature types that our attributes aren't matching up. This is because Oracle does like them in uppercase. So what we can do is we can right-click on the connection here, and we can select Auto Connect Attributes. And then right-click and replace link with Attribute Manager. So what this does is it changes the case of the input attribute. So we're going from mixed case here, or title case, to our uppercase for Oracle. And this is a great way to document and maintain that change in case that you've done. Another way to do it is using the bulk attribute renamer. So for example, we can rename all attributes, change case, and we can change it to uppercase, lowercase, title case, or full title case. We can stick to using the attribute manager in this example, though. I'm going to turn run with prompt off, so I don't need to be prompted about my input and output locations. And we can run the workspace. Once it's ran, we can inspect our output table. And we'll see here now that the table is stored in Oracle. So we have our schema, FME, and our table name Downtown Public Art. Just opening back this back up. If you wanted to use the drop and create or truncate existing, you will have to set the feature operation to insert. So the only way you can, for using update or delete, these were what you're going to be using for use existing, and that's where you're going to set your match column or your where clause, and we'll look at this again later on. So insert, you can use use existing, create if needed, drop and create, or truncate existing. Okay, so if you want to save the workspace, you can go ahead and do that. I'm going to create a new one. I should remind you that if you are saving onto these virtual machines, they do get terminated at the end of the week. So just make sure to email yourself the workspaces if you want to save them. This time we're going to generate our workspace. So this is a little bonus exercise that Mark and I have conducted for you guys. So we're going to go generate. I'm not going to save that. And this is where we're going to generate a workspace to read from PostGIS and write to our Oracle database in order to get those remaining tables into our Oracle database. So our reader format is going to be PostGIS. We're going to add a database connection. Our name you can just leave as or set as PostGIS training database. Our host is postgis.train.safe.com. Our port is the default 5432. Our database is FME Data. Our username is FME Data. And our password, you guessed it, is FME Data. Now let's test this. So I'll leave those parameters up just for another second here.
You have to set the schema after this.
Yeah.
Okay. That's right.
Okay, so hopefully you've been able to successfully connect to the database. If not, do let Mark know. So we can go ahead and save this. We open up the parameters. We're going to set the schema for table listing. So here on the reader, we're going to set which schema we want to read our tables from. So we're going to read them from FME Data 2015. So the loading's in the way there, but I've just gone to schemas for table listing and select FME Data 2015. Now in our table list, we will see that we only have the one schema here. And we're going to read in bike paths, downtown parks, fire halls, food vendors, and parks. So I'll just expand this. So once again, that was bike paths, downtown parks, fire halls, food vendor, and parks. So the parks and the fire halls we were using in a previous exercise. So if you wanted to on a break go through the exercises using those tables, you most certainly are welcome to. And now they'll be in your database if you want to use them later today or tomorrow as well. So we'll hit OK. So we're going to be reading in multiple feature types here. And for our writer format, we are writing back out to our Oracle training database, so Oracle Spatial Object. We've gone to our training database. If it's not there already, just select that one. Parameters, we can leave that as is. Now we're going to select OK. So what you'll see is FME has read in the PostGIS table and connected it to the Oracle table. I'm just going to just expand this a little bit so we can see what's happening. My attributes have been auto-connected. If yours aren't, you just need to right-click and select Auto Connect Attributes, and that's just because of the difference in cases. So I'll give you a minute to do that if you need to. Now you'll remember that in our Oracle database, our schema is called FME. It's not called FME Data 2015. So we'll just have to go ahead and edit our feature types here. So we can leave it as Parks, FME. So just go through each of them and change the table name. So remove FME Data 2015 in the period, and you can add your table qualifier. You'll notice for all these that we are leaving our feature operation as insert and our table handling as create if needed. That's because we're creating new tables in our database, so we can leave that as is. Okay, so once you've changed all of your feature types to the proper table qualifier or schema, you can just go ahead and run the workspace. We're just going to move on to our next exercise, converting to Oracle right to an existing table. I'm going to create a new workspace again. And we're going to be looking at this guy here. So as you can imagine, when you're writing to a database, you're not always going to be creating a new table each time you write. Sometimes you're going to be wanting to write to an existing table. And the workspace should reflect the table data model or schema that already exists. We can accomplish this by importing the table schema from the database when we're adding the writer. And what this does is it sets up the attribute names and data type, so the table definition in FME, so we know what we're writing to and how we are writing it. So we're going to download the bike paths _L sample data here. Let's close this. I'll just go ahead and message out the article to everyone. Oh. And what we're going to do is we're going to drag and drop the bike paths zip file onto the canvas. We're going to have to tell FME this time that it is a shapefile we're reading from, just because since it is a .zip, it's not as obvious as the .csv was. So we can just hit OK. So now that we'll see we have the bike paths on. So you can just download it from the article here and just make sure you specify that it is a shapefile you're adding onto the canvas. And then for this exercise, we're going to be setting the table definition on our writer to import from dataset instead of copy from reader that we've done before. And what this is going to do is it's going to prompt us for a dataset that we are getting our table definition from. And we're going to be doing this from our Oracle database, and we're going to use that bike paths table that we just wrote into the database from PostGIS. So I will leave you about 5 minutes to get started on this article here, and then I'll come back and we'll just go over it together. So just make sure that when you are adding the writer, you do specify import from dataset, and then you can just follow along with all the parameter prompts. The table that we are importing from is support.bikepaths. Make sure you set your table handling to use existing. So I have my bike paths shapefile added onto the canvas. And now I'm going to add my Oracle Spatial Object Writer. Oops, that's my reader, wrong one. Spatial object. We're writing to our Oracle training database, and our table definition is going to be import from dataset. So now we have to select where we want to import our writer feature types from. We're going to import it from Oracle, the training database. In our parameters, we'll select our table list. We're going to select the bike paths table. I have two tables here just because I did load an additional one in the previous exercise with Postgres. It looks like one of them had an underscore and the other didn't, so I've created two tables now. Hopefully you have at least one of them, and then you can just go ahead and select it. And what this is going to do is it's going to bring in the attribute name as well as the data types from this table that already exists in our database. Let's move this down here. We can go ahead and connect the reader to the writer. We open up the writer, the feature type. We can see that we've brought in our attribute names. They're all uppercase here. We can leave the table name, or you can move the schema down to the table qualifier. And now we don't want to create if needed. We're going to use existing because we do know that this table already exists in our database. We know this because we've imported the feature types from the table. We do have that case mismatch with our attributes, so we can go ahead and auto-connect attributes, or if you wanted to, we could try out the bulk attribute renamer here. And we can change the case and set it to uppercase. All right, everything's a green now, so we can go ahead and run the translation. If I inspect my output, you'll see I have a lot of rows here. So I have about 1,700. You might have less than me. You probably will. This is because each time the workspaces run, we're just going to be inserting new features into the table. So now when I go back and view the table, now I have 2,100. So every time you run this workspace, it's going to write those features into the table again and again. All right, we'll move on to our last exercise of this tutorial series, how to convert Oracle Spatial to Shapefile. We've just done Shapefile to Oracle, so we are going to switch this up a bit. We're going to write out into GeoPackage instead. So I'll create a new workspace. Feel free to save yours if you want to. And here we're going to be reading the food vendor table from our Oracle database that we've loaded in through our Generate Workspace exercise when we went from PostGIS to Oracle. And we're going to be setting up a where clause on this to limit our vendor description to hot dogs. So the data we have in the database, I'll add it and we can look at it together, and then I'll let you do this exercise on your own again. So we'll add our Oracle Spatial Object Reader. And we'll read our food vendors. So if you don't see all the tables that we've written from Postgres or PostGIS here, please do let Mark know. And if we find that a lot of you are missing the tables, we can go through that exercise again quickly. But you should see them here that you can select from them, provided that you have chosen Oracle Spatial Object as your reader and you wrote to Oracle Spatial Object. So let's just add that onto the canvas. Doing a quick inspection, we can see here that we have point data and we have various food vendors here. So we have our vendor name and our vendor description. There's quite a few different types of food here. So we have sandwiches, seafood, comfort food, hot dogs, pizza, a lot of hot dogs, Thai food. So we're going to be using a where clause to limit which vendor description we read in. So we're just going to want to read in the hot dogs. So we've done a where clause in a previous exercise. And like I said, we're going to write out into GeoPackage instead of Shapefile. So I'll give you another 5 minutes to work through this one, and then we'll just go over it again. If you don't have the food vendors table available to add to the canvas, it's all right. We have gone through a where clause before, so we're just reusing that in this exercise here just to write out to GeoPackage. So it's a very similar principle to what we've covered before. I can go through it now, and then should you want to try it with a different table you have later on, please feel free to do that. You just need to find an attribute whose value you can set for your where clause. So I have my food vendors table added onto the canvas, and I'm going to set my where clause on the feature type this time. You could have done it in the navigator like we had done before, whichever way you would have preferred, that's fine. And here we have our where clause. The nice thing about setting it in the feature type parameters here instead of the navigator is when we go into the text editor here, we can see our database table here and select which attribute we want to plug in. So this is useful if you have a lot of attributes or there's convoluted spelling or anything like that, and you want to minimize any likelihood of errors. So I'll just double click like we did with the publish parameter earlier. We're going to set it equal to hot dogs. You can choose a different food preference if you want. I'm just going to keep it as it is in the article and use hot dogs. So now we'll see it's filled in on the where clause in the general section here. You could have also just typed it in if you wanted to. I just like using this to minimize the typing and any errors that I might type in while running through the training course with you. We can go ahead and add our GeoPackage writer. So we'll use the OGC GeoPackage and select a location to write it. I'll just write it in the documents again, and I'll name it food vendors. We're going to change our table definition. We don't want to import from dataset anymore. We can just leave it as automatic. And now we can give it a more meaningful table name, which I'll name it hot dogs. Connect up our reader and writer. Attributes look good. And now I'll go ahead and run the workspace. I'll inspect the output. Now we'll see that we've written the 76 hot dog stands in Vancouver to our geo package. All right, so that was the last exercise for the getting started with Oracle. We're going to be looking at updating databases next. So if we go back to our training resource page, close all my tabs here. We go back to Mastering Spatial Databases, our resource page. We're going to be looking at the tutorial Updating Databases now. So we're going to be looking at updating databases. I understand some of you don't have the Downtown Parks table in your Oracle database. No worries, we're going to walk through creating that just after I go over a brief introduction on what the exercise is actually about. So we do have FME update modes, like I mentioned previously, that can be done through the feature operation and table handling. So those are applied to the whole table. You can update individual features using the FME DB operation. So we're going to be using that in the next exercise. Mark has messaged out the link. So we'll be looking at updating databases using change detection to set FME DB operation. We'll also be downloading some MyTab data from the article here. So if you don't have it open, please do open it so you can follow along. We'll just download the Downtown Parks for Oracle right there. So like I mentioned, in this exercise, we will be using the FME DB operation. And what this is an attribute where we can set the value to update, delete, or insert. And this is going to send those commands to the database to perform that action on the feature on write. You can set this on the feature type like we did before. We had set at insert, but you'd have to have multiple feature types if you wanted to perform all three operations. So it's not recommended. However, using the FME DB operation is a quick and easy way, and it only allows you to use one feature type to send these updates, inserts, and deletes to your database. So before we get started, let's load the table to make sure that it is in our Oracle database. So we're going to re-add our PostGIS reader. If you were like me and you saved the connection from last time, you can go ahead and select it. If not, I'll just go through the connection parameters again. So you can provide it a name, and the host is postgis.train.safe.com. Port is default 5432. Database is FME data. Username is FME data. Password is FME data. So you can just go ahead and test to make sure that you've connected. So I'll leave those parameters up for just another second. If you have selected If you have saved it previously, just go ahead and select that named connection, while others add the connection now. All right, so once you have your database connection established, we're going to go into our parameters. You'll see that we're still reading in all the tables we picked last time. So a quick way to uncheck them all is just go select all and deselect all. And we're going to grab
FME Data 2015 schema.
Yep. Oh, right up here. Downtown parks. I missed it when I was reading through them. Oh, yeah, so just grab the downtown parks table in the FME Data 2015 schema. If you haven't set the schema, you can do it up here as well. Schema for table listings. So this is what you should be setting up to add onto the canvas. And then just hit OK to get it on. Now we're going to add an Oracle Spatial object. So make sure you're adding the spatial format here. So Oracle Spatial object is your writer type, because we are writing spatial data into the database. So these are the parks that we were supposed to have read before. So they are just polygon parks of in Vancouver area, and in PostGIS we've just limited it to the downtown parks. So you just write to your Oracle training database, leave the table definition as automatic. Make sure you are using the spatial format. Let's give it a more useful name. So downtown parks. I'm just gonna go _2 for mine because I do have 2 tables. I already have downtown park stored in mine. I don't want to add more features into it, so I'll just write it to a different table. But you can just go call yours downtown parks. You don't need the 2 there. After you have that set up properly, just go ahead and connect the 2. If your attributes don't match, just make sure you do the auto connect attributes, and just ensure on your feature type you have it. Select insert
And drop and create. Well, just in case they created it.
Oh, and you can, if you do have the table already, if you're not sure, Mark just added that we should just select, drop, and create. So I'll actually do that with mine too, so I don't need to have the 2 tables. And what this is going to do is if you have downtown parks already in there, we're just going to drop and create or recreate the table. That way we don't get multiple or duplicate features. And if you don't have the table already, we'll just create it when we run the workspace. And go ahead and run. And we'll just do a quick inspect. We'll be looking at this again once we start the exercise. You should see some polygons and 19 rows of park information. So we do have our park name here and our neighborhood name, which is downtown, and then some information about features such as dog park, washrooms, or special features. So we're going to be reading this table back in for the exercise, so I'll just go over what's in there right now. So we do have the 19 parks. You'll notice that Harbor Green Park as well as Cathedral Square are missing some information. So both of them are missing East-West Street as well as North-South Street, and washrooms and special features information. So just keep this in mind when we start looking at what's in our MyTab data set. All right, so we can create a new workspace, or you can just delete the readers and writers from your canvas there, whichever you prefer. And now we're going to add our Oracle Spatial Object Reader to read in the table we just wrote out. So we're going to use the Oracle Training Database. We're not reading in food vendors, we are reading in the downtown parks. So we've just read in the polygon features that we've just wrote out to Oracle. And now we can drag and drop the zip file we've downloaded from the article. So we've used the downtown parks for Oracle. Drag and drop. We have to tell FME that it is using MyTab. So these are MyTab files that we've zipped up. And we'll go ahead and add that. So in this exercise, we have two different sources for our downtown parks. We have our Oracle database, which is a table that we have stored inside of Oracle, and this is what we've taken to be our original data set. And then we've sent somebody out into the field to go around and verify all the attributes that we have stored in the database. And this is what the MyTab file, or the MyTab data set is. It's someone who's gone around and looked at all the different parks and seen their special features, their washrooms, etc. So if we just want to open it up and inspect, we'll see that we have 18 parks here instead of the 19 that we have stored in our Oracle table. So if I just switch back, we'll see we have 19 there. So what this tells me is that when someone has gone in the field, they've verified that one of these parks no longer exists, as well as they were able to verify for both Cathedral Square and Harbor Green that there are no washrooms, no dog parks, and no special features. So we want to take these updated features and write them back into our database, so now that the database will be more recent and reflect what's actually out there. So we're going to be using the update detector to do this. I'll just maximize this now that we're done with the article there. So if you just want to add the update detector, our Oracle database table is going to be the original source, and the MyTab is going to be the revised. And what the update detector is going to do is it's going to compare these two data sets and see if there have been updated, inserted, unchanged, or deleted features. Updated features are those that exist in both data sets, but the attributes have changed in the revised. Inserted are ones that don't exist in the original, but exist in the revised. Unchanged are ones that match each other in both, and typically we don't need to write these back out to the database because they're already there and they're already up to date. And deleted are ones that exist in the original and do not exist in the revised. So let's just open up the update detector. Our key attribute is going to be park ID, which is a unique identifier for each park. We're going to turn match geometry to none because we just want to update the attributes in the database. We don't really want to update the geometry right now. And the attributes to match is we're going to select all of them. So we're going to compare all of them to see if any have been updated. So our key attribute is park ID, match geometry is none, lenient geometry matching is no, attributes to match, we've selected them all. And we can just leave the bottom two parameters as is, so no and 0. So it's a good idea to attach some inspectors to make sure that the update detector is doing what we want it to do and that we've configured it properly before we send any features to be deleted or updated in our database. So if you want to just click on the transformer, you can right-click and select Connect Inspectors. This will add all 4, so you don't need to do them individually. And we can just give this a run to see what comes out of each of the ports. So we see that we have one deleted feature. FME DB operation has been set to delete, and that's for Portal Park. So remember when we were inspecting both tables from MyTab and Oracle, we noticed that Oracle had an additional park. So that's this Portal Park. So if we go back to our MyTab, we'll notice that Portal Park is gone from here, but it was existing in our Oracle database. We have 16 unchanged parks. We don't really need to inspect those too much, but let's look at the updated. So we see that Harbor Green and Cathedral Square have been updated to include the dog park, washrooms, and special features information. So if we go back to Oracle, we'll see that washrooms and special features were missing. You'll notice that EW Street and NS Street are still missing. That's because in both data sets, they don't have any values, so we can't update them if we don't have the values known to send to the database. But we can update the washrooms and special features. All right, so now that we know that looks good, we can add a writer to send this to our database. So I'm just going to delete my inspectors and add an Oracle Spatial Object Writer. Still using our Oracle training database connection. And since we are writing to an existing table, let's import from data set. So we're going to send these updates and delete back to the table, so we don't need to have multiple versions of the same table. So same as before, we're going to use the named connection we've created in our parameters. We'll select our downtown parks table. And we're just going to bring in the feature definition from this pre-existing table. So once we hit OK, we'll see that the feature type's added to the canvas. We open it up. We have our user. In our user attributes, we see that we have the name and the type, and it's all been specified for us already. Hit OK. Now what we're going to do is we're going to connect our updated, inserted, and deleted to the table. Like I said, we don't really need to write the unchanged data back into the table. If you are using an older version of FME, you will need to use an attribute creator to set your FME DB operation to either update, insert, or delete, but we don't need to worry about that in 2017. So once we have those all connected up, if you really wanted to, you could attach a logger to your unchanged port, and that way the features will be written into your translation log, and you can check them out there. So if we go ahead and open our feature type, now we're going to set our feature operation. We're going to change it from insert. We're going to use FME DB operation. So once again, this is an attribute that either has the value insert, update, or delete on it. And then those features are going to do that action when being written to the database. Table handling stays as use existing. We can set no to update spatial columns. And now we have to set our match columns. So this is going to be our park ID. So this is our unique identifier. And what FME is going to do is it's going to, as it receives each feature, it's going to check to see if its park ID matches what's in the database and then use that FME DB operation. So once again, feature operation is FME DB operation, table handling is use existing, and our match columns are matching on park ID. Once you've got that all set up, we can hit OK, and we can run the workspace. So we see that 3 features have been sent to the writer. Those are the 2 that have been updated and the 1 that's been deleted. In this example, we really didn't need to connect the inserted port, but it is good practice just in case when you're doing this, you have features that are inserted. So let's inspect the the table we've just written to. And we'll see now that we have the 18 parks like we should, since it's been verified with our field technician, as well as our washrooms and special features have all been filled in. So Cathedral Square and Harbor Green are filled in.
Yesterday we had a little bit of a glitch with some of the tables that we were working with, so we're going to look into why that happened as well just before we kick off the day. If you've had trouble restarting your virtual machine or getting access to that, ping us and we'll try and get you going. Again, myself, Mark Stokes, and I'm going to be doing most of the presentation today. Tia is going to be doing all the Q&A for you, so fire off lots of questions. Tia did her mid-term on a SQL course last night after she'd run that training course, so she's all ready to take your difficult SQL questions if you've got any that you need to fire off. So day 2 agenda, we're going to be working through some of the other ways that we can work with databases in FME. So we're going to be looking at some of the transformation tools. So yesterday, Tia largely went through reading and writing to the database, to our Oracle database, using the readers and writers available in FME. But we have quite a large number of transformers in FME that allow you to also access your database in various ways or do database-like operations. And so we're going to be running through those today. So that's going to be the focus, and that's more or less the agenda. Tia, I think, has already posted out on the chat channel the link to the starting place where we're going. So let's get out of this. Yep, just a reminder, your Oracle database connection, you should still have that from yesterday. If you had to start a new virtual machine, those are the connection parameters, so you can take a screen grab of that if you need them. But you should already have a connection called the Oracle Training Database that you'll be able to use for most of the examples that we're going to be running through. Okay, so we're going to be working from the Mastering Spatial Databases document, and that's going to be our starting point for the day. And we're going to be starting here at working with database transformers. All right. Before we get there, yesterday we had a couple of glitches with the database tables that some of you had on some of your virtual machines. So that looks like a good excuse to go into some of the resources that we do have for troubleshooting with Oracle, and we've got equivalent ones for some of the other databases we work with. So down at the bottom of this document here on the Mastering Spatial Databases is we've got a link to the FME and Oracle Troubleshooting Guide. So if you are ever having connection problems or difficulty getting access to your Oracle database or any other errors popping up, have a look at this troubleshooting guide. It's got links to a wide variety of other articles about how to connect to the Oracle database, why you might not see an Oracle Reader and Writer, and so on. And here we are. This is the root cause of the problem that we saw yesterday. My Oracle tables are not showing up in the table list. And so the problem yesterday was that for some of the machines, and we don't really know why at this point, but down here on some of the machines, the metadata entries for the SDO-JOM metadata was not getting loaded correctly. And if that happens, then the Oracle Spatial Reader will not see the tables that you think you've got. The Oracle non-spatial reader would see those tables. And I think some of you did figure that out as well. So if you create tables with FME in your Oracle database, FME should create the entry, the appropriate entry into the SDO-JOM metadata table. If you create tables manually, which a lot of you do, and you do have to make sure that that entry is created, it's got all the spatial domain bits and pieces that you need to effectively work with a spatial table in Oracle. So that's a really great resource. Have a look at that if you're working with Oracle a lot, and that should help you with any problems that you have working with Oracle. Okay. So to kick off the day, we're just going to start working with the database, looking at working with database transformers in FME. As I said yesterday, you largely walked through using the reader and writers in FME to access your Oracle databases, mostly Oracle Spatial. And so we've got a bunch of other tools that you can use to access your database. If you are a strong SQL user, we have a couple of transformers called the SQLExecutor and the SQLCreator. We're going to walk through these all in a bit more detail later on, so this is just a little bit of an introduction to these. So SQLExecutor and Creator are transformers where basically you can just fire off any SQL statement to the database, and it doesn't even have to return a result. So within these tools, you can create and drop tables, do a database, more complex database join to return more complex results, or any other SQL statement that you might want to throw at your database, like building an index, building a spatial index, and so on. So those are, if you're a strong SQL user or you want to learn SQL, that's a good place to start. The FeatureReader is a transformer that was really originally aimed at allowing people to do more complex spatial queries to a database. And somebody did ask us a question about that yesterday. The Oracle Reader allows you to put in a bounding box and do a simple spatial query. Did you look at that yesterday? Build a bounding box for doing a spatial query?
Oh, we touched on where to find it in the navigator.
Yeah, okay. So you had a quick look at that. And so that's just a bounding box. So the FeatureReader allows you to, along with a whole bunch of other interesting things that we'll try and cover today, but it allows you to send a more complex polygon to the Oracle database and have the Oracle do a more complex spatial query. So that's pretty useful. The FeatureWriter is another way to write out to any format in FME, including your databases. The advantage of the FeatureWriter is that it allows you to write to your data midway through your workflow. And so you can then do some follow-up operations after all the data has been written. And that could include anything from checking the data was loaded correctly with SQL statement, building a spatial index, building attribute indexes, and so on. So that's good. And actually, the FeatureReader is also the same there, except it allows you to do some database work on your database before you read from the database. So that might include doing some database cleanup, dropping indexes and so on. So that's also a good thing you can do there, is use the FeatureReader to read data so that you can do some early on stuff in the workflow before you start reading. Data joins, so we've got a variety of ways of working and joining data in FME. The Joiner Transformer, now renamed to be the DatabaseJoiner, allows you to do a very simple query to the database. The InlineQuerier is kind of an in-memory query tool, so you've already read the data, and it allows you to do SQL joins and queries on the data that you've already read. And where we're going to start today is the FeatureMerger, which is the simplest tool for sort of merging together data in FME, and that allows you to do very simple joins within memory within your workflow. So that's where we're going to start today. So we're going to start off with the FeatureMerger and just looking at doing joins in your database, or on your data, I should say. So the FeatureMerger is not restricted to database data. It allows you to join any data that you've read. So that is kind of useful, because sometimes you are reading perhaps data from a database, and then maybe you've got a big CSV file that you actually need to join in and merge to that. So you can't do a SQL join on that, because CSV doesn't understand anything about SQL. And so the FeatureMerger would allow you to read from your Oracle database, read your CSV data, and then do a simple join there. Before we touch on that, though, just want to make sure that everybody and anybody taking this course should understand this, because you should have all run through at least an FME basic training to get to this course and understand a little bit more about FME. But there's a very distinct difference in FME between appending and merging or joining data in FME. And it's kind of a subtle difference, really. And so we've got an example here showing two tables being appended to each other in FME. And that happens basically when you have two connectors just converging on an import port. And that could be an import port on a transformer or a feature type, as in this case here. And that data is just appended, i.e. it's just tacked on to the end of the first set of data that's being read there. Whereas merging data or joining data is where you take two tables and using some sort of a key, you join them together like illustrated here. And the FeatureMerger is a very, very simple example of doing that in FME. So let's have a look at a simple workspace there. So we're going to go to the example at the bottom here, the example workspace. You should be able to click on that and get that downloaded somewhere onto your machine there. And then if you right click on that and open it up in Workbench, takes a little while for these machines to wake up in the morning. There we go. So it's just a simple workflow, reading a few spreadsheets and joining them together or appending them. So in the first example up here, we've got an operation that's appending the data. So we've got two tables of or sheets of tree data in our Excel spreadsheets, and we just want to bring those together into a common table, so the Vancouver trees. So that's that example there. And in the second case here, we've got the downtown trees table or sheet, and we're merging that or joining that with the species of tree and creating additional or adding value to that data. In a database context, we could think of that as being denormalizing, I think. So we're moving from a normalized database structure with a tree species and merging that onto a single table. So you should be able to run that pretty quickly and have a look at the results there if you want in that output spreadsheet. I don't think we've got Excel on these machines, so we can't open that result in Excel. Okay, and there we should see the genus and species of the trees that we merged in from that other table that we had in the genus and species tree. Okay, so that's a great simple start to the day. Just to warm up and get our fingers doing some work, what I'd like you to do is, instead of writing this data to an Excel spreadsheet, why don't you see if you can take a couple of minutes and write this data instead to your Oracle database. So instead of writing the Vancouver trees and the fully named trees to Excel, why don't you add a Oracle non-spatial writer and write those to two new tables in your Oracle database. Give you a couple of minutes to do that. Okay, how's that going? So what we could do here is we can add a writer to our workflow, and that will be Oracle. And I'm going to choose the Oracle non-spatial writer, and that'll be my Oracle training database. And we can say copy from reader here. There are a couple of parameters to watch on your Oracle writer, depending. Remember that Oracle defaults to FME defaults to writing Oracle or all the attributes in uppercase. So if you want title case or mixed case in your Oracle database for attributes, then uncheck that little button there. Otherwise, you're going to get uppercase attributes. Actually, I'm going to leave that alone there because it does illustrate an interesting thing that Tia did cover yesterday. So then the second thing is we could copy these tables from the readers, but I'm going to do a slightly different approach here. And that is I'm going to say I don't want to add any feature types to my workflow. So all I'm going to do is add an Oracle writer, but I'm not going to add any feature types. So up here you can see in the navigator I've got the Oracle writer added, but I haven't added any feature types there. So this is a really good way of transitioning from one format to another. Like if you're doing some testing, you might be writing to CSV or Excel. Maybe you're doing the work at home and you don't have access to your Oracle database, but then when you get to work, you want to switch over. So what we can do is just go into the properties here and just switch over the writer and say, okay, I want that data to be written to Oracle instead. And we can do the same on the second table there. And then you should be able to run your workspace and get that data written out to Oracle. So that's one very quick way of switching from one writer to another. Probably people working in Esri geodatabases do that more than anybody else, because often you start testing a workspace against a file geodatabase and then you need to switch over to a more enterprise SDE-based geodatabase. So that's a really good way of doing that. Okay, so that's great. very quick way of setting up our workflow and writing out to Oracle. Hopefully everybody was able to do that. So that's the FeatureMerger. Simple transformer for doing simple joins in FME using a key. In this case, I didn't actually open up the FeatureMerger there, but the key that we're using would be the tree ID in there to make that join between the downtown trees and the species of trees table that we've got. Actually, no, I guess we wouldn't have done that. We would have used the common name. Okay. So next up, DatabaseJoiner Transformer. So the database joiner is somewhat similar to the FeatureMerger transformer, but instead of having previously read the two streams of data, in the previous example we had read from two different spreadsheets, the database joiner is triggered by some input features, and then it goes off and reads the data from a database. In this example here that we've got, you can see we're reading from a Postgres database. These are the database joiner parameters. You choose which table you want to read from the database, and then build up the key in there. Choose which fields that you want to load in from that new database table, the cardinality, and then there's a bunch of other attributes, parameters around choosing how the attributes are joined to the new data. So what we're doing here is merging from a database table to existing features that you've already read in FME. Okay, so the actual example is doing a simple join to a database table in our main document there. Some of these do have little movies, as you saw yesterday, so if you need to come back and recap on these, you can do that. And what we're going to do is start off this little example by downloading a starting workspace so that we don't have to work too hard early on in the day. So we're going to grab starting workspace as a template file, and that will give us that I think I should have just, there it is. That's coming up there now. Okay. And I'll open that up in a second. Okay, so the source data for this example is, oh, there it is. Go back here. Is a CSV file that we've read. It's some crime data from the City of Vancouver open data set. Tells us what kind of crime is happening and more or less the block number that's going on. It's been obfuscated a little bit so that you can't actually trace down the individual buildings that the crime is happening on. And what the data analyst wants to do here is join that data to a roads data table and pull out the type of road. So we want to see whether crime is occurring on residential streets predominantly or arterial streets and so on. And so we're going to use the database joiner to grab that data from, hopefully from our Oracle database. Hopefully we don't have the same glitches as yesterday. Okay. So we're going to use the database joiner to join the two data sets, the data that we've read already from the CSV file, and going to build a database reader that will join to that roads database table that is in our Oracle database. Okay, so we've got the starting workspace, reading that CSV data, and again, remember you can always just quickly click on the feature type and inspect the data just to see what that looks like. It's a good thing to do. And so this is the CSV file that we've got. We've got the type of crime that is occurring, the month, and the block that is occurring on. We're going to do the join to the roads table using the block name or the street name here. The thing is, in our roads table, what we have is data that actually has the full block number on it. So instead of having XX here, 700-7XX, it'll be the 700 block or the 1700 block. And so we do need to manipulate this data slightly. And so what we've done here is we've added a simple string replacer transformer to switch XX to 00 to make the block number. And then we're using the case changer to change all the street names to title case, which will match our roads table. And of course, if we were not familiar with that roads table, what we could do is we could open up that data in the reader here. And I think it actually is spatial data, so we might as well use the Oracle reader. I'm going to use my Oracle training database connection. Go to the parameters and choose roads. There we are. We can see the roads. We've got the H block number, so that's the street name with the 00 there in title case. And we're actually interested in the type here, the residential street type, whether it's residential, arterial, I don't know what else is in there. Residential and arterial, I guess. Some of you may not have a background map showing in your data inspector. And if you want a background map, you can subscribe to various map services. So under Tools, FME options in your data inspector, you can choose what kind of background map you want to get hold of. Many of these require you to subscribe and get an API key, like the Mapbox one. When you go to the parameters, you have to have an API access token, so you have to actually sign up to Mapbox and get the free account and so on. So what I have chosen here is the Stammen maps, because that has some very simple maps that are very effective, don't require any prerequisites, and I have just chosen the terrain map there. So if you've got some spatial data and you want to see that in the context of some background information, using Stammen maps, the terrain background is pretty effective. So that's what I've got here. So my roads, Vancouver roads data is being overlaid on that background map. Okay, so let's go back to our workspace. And what we're going to add to our workspace is the database joiner. You've got the parameters here for joining to a PostGIS database, but we're going to be joining to Oracle. So let's have a look at the database joiner, add that in here. If I can type so early in the morning, there we go. In older versions of FME, you might have seen this before. It used to be just called the joiner, so now we've kind of renamed that. And going to set up the parameters here. So we're going to read from Oracle. And the data set is going to be our Oracle training database that we made yesterday. You can check any of the parameters there if you need to. And here we can select the table we're going to work with, which is the roads table. And now we're going to do this, the join. We're going to build that join key. And it's going to be the block This side of the key, the feature attribute, is coming from the CSV file that we're reading. So this is the key that's coming from this side of our data. And the table field for the key is coming from the database table, which is the H block value. You can just see that down at the bottom of my screen here in the document on working with the database joiner. And then the fields to add, and I'm just going to choose the type. That's all we want is what type of street, residential, arterial. So this raises an interesting question here that may arise sometimes. You can see that we've got a type attribute here coming in from our roads table, but also in our CSV file, we've got another type attribute. And so sometimes there is a conflict between data that you're merging together. Now, in this case, we're lucky because FME is case sensitive. So in the CSV file, the type attribute is uppercase T, title case, and in our Oracle database, it's just all lowercase type. But what you're going to see on a lot of the transformers, in fact, pretty well all transformers that merge data together in some way, you'll see a merge attributes panel somewhere towards the bottom of the transformer, and it will tell you how the database is going to accumulate and what kind of conflict resolution you want to have. So if the type attribute here had the same case and there was a conflict, what do you want to do about it? And so often what you can do is you can add, sometimes it'll give you the option to add a prefix. Down here, how do we get to the prefix, the joined? So if there was a conflict, we could add a prefix to that so that we could slightly change the name, and so we're not going to get a clash between two attributes that have the same name. We don't need to do that today, but that is something that always to be aware of, is that the merge attributes down towards the bottom of these, many of these transformers allow you to resolve these kind of conflicts that might occur between attributes that you're merging from different tables. Okay. The other thing you can do in the database joiner is to somewhat optimize your query. And so what that will do is it will allow FME to read a block of the data and actually do the memory in the join in memory. And so we're going to do that. We're going to set a prefetch query here. And so we're going to go into our SQL editor, which is available in many places. We're going to see that quite a bit today. And you can get a look at your database tables here. And if you've got a database with many tables, remember you can use filters in here just to thin down the number of database tables that you're looking at. And so we're going to add a prefetch query in here. And we're just going to say select star from roads. And so we're going to preload all the data from the roads table and then do the join in memory. The advantage of that is that the database joiner is triggered by every single input feature that runs into it. And so that could result in a large number of individual queries going to the database, which would probably annoy your database administrator. And so this is a way of reducing the number of queries that you send off to the database. This is really good if you're doing problems, actually more similar to that first problem we were looking at with the FeatureMerger, where we were joining the tree species to the trees table, denormalizing the data. And so you've kind of got a more of a lookup kind of table, which is generally smaller than the data that you've read. And so you can do a prefetch query and pull the data in a block. And it's going to be an exhaustive query, which says that's all the data that I want to read. And then we can add in a couple of data inspectors. and run that and see what we get. And so you can see now that we've made that join, and we've got the type, which is the type of crime, and we've got the type attribute, which is the road type. So we would probably want to add a attribute manager after this to rename that to be road type or something, and get that data out. We've got a few unjoined records here, so we don't know what those blocks are, so we'd have to possibly deal with those. And again, as just a little warm-up exercise, what you can do is spend a couple of minutes and write this data out to a crime table in your Oracle database. So I'll give you a couple of minutes to do that and catch up. Okay, so to write that out to an Oracle table, we would again add the writer. In this case, it's non-spatial data. So I'm going to write out to the Oracle non-spatial, choose my Oracle database connection. In this case, I am going to copy from the reader. So that's the reader being the CSV file that we're originating the data from. There it is, so sort of a redemption of that data. Make the connection. Notice how I didn't set the title case, so we've got a mismatch in the attributes here. So we can right-click on the link and do a auto-connect attribute, which is a best guess. So that will swizzle our mixed title case attributes into uppercase, and we do need to add the road type attribute in there, so I'm just going to add that in there. I can type, and that's a character string as well. And then maybe back in the parameters, we should give the table a decent name. And then we can match that across as well. Now, my own preference is that I don't really like having attributes mapped manually across here. The reason being that when you close this and clean up your workspace, you don't really know where that attribute mapping is occurring. And so if you have had to do some manual attribute mapping or using best guess, I think Tia showed us this yesterday, you can right-click here and replace that link or insert into that link an attribute manager, which will just show you where all those attribute renaming is going on. So that's a really good way of documenting, I think, a bit more clearly where the attribute renaming, which it doesn't look like it's being renamed except for this one here, but the renaming FME is case sensitive, so we've renamed it to uppercase, and we've put that attribute manager in there. Okay, and then you should be able to run that. Now, I am writing to a non-spatial database, and that's because the database joiner is a non-spatial join. So it's not carrying across any of the geometry that came from that roads table. It's just reading the attribute table only. Okay, so that's a quick look at two transformers that allow you to do simple joins without knowing anything about SQL. One of them, the FeatureMerger, allows you to do a simple join in memory. So you pre-read the data, throw the data into the FeatureMerger, and FME will make that join. The DatabaseJoiner allows you to connect to the database midstream and read that additional data or join that data midstream. And I would say the DatabaseJoiner is probably more geared towards the kind of join where you're reading quite a lot of data from the source and you're joining to a smaller table, some sort of a lookup table or domain table to get descriptive values or whatever. And that would be a more typical use case for the DatabaseJoiner. Right. Have we had any good questions around that? Yeah, Tia?
Yes.
Okay.
But you've kind of just gone over it. So is when would you use a FeatureMerger versus the joiner?
Right. Well, the other reason you might use the FeatureMerger is the DatabaseJoiner is focused on databases, and so the FeatureMerger would allow you to actually do a join to almost any data set. So it could be Oracle to CSV, Excel to Excel, and so on. So there's a little bit more flexibility in the FeatureMerger, I would say. Okay. So now we're going to go on to another way of getting data into FME, and that's using the FeatureReader transformer. So the FeatureReader is a reader in its own right, similar to the DatabaseJoiner. The read is triggered by a feature coming into the FeatureReader. We call that the initiator feature. And typically that is not like the DatabaseJoiner. It's a single query, that feature that you might push into the FeatureReader. So it might be a feature that you've read that is a polygon. So you're going to do a spatial query back to the data that you're reading. The FeatureReader is not restricted to database formats. In fact, you can read any format that FME supports within the FeatureReader, and that can be spatial or non-spatial data. We'll have a look at that in a little bit. One of the advantages of using the FeatureReader outside of being able to do a more complex spatial query is that it does allow you to do a little bit of pre-processing on your data before you read it, if you need to do that. And so that could be around creating tables that are going to be the destination tables for your data before you write to them. So you're going to do some pre-processing, create some tables, start reading the data that you want to read, and then write to those tables that you've created or dropped indexes on or something like that. So there is a lot more flexibility there than if you are using a regular reader in FME. Okay, so let's start an exercise, and then we'll have a little bit closer look at some of the details of the guts of the FeatureReader that we're going to work with. So we're going to go off and look at performing spatial queries against database tables using the FeatureReader. That's a little exercise that we can do there. Okay, and so what we're going to do in this exercise, just to introduce it, is we're going to read some data. So we're just going to download this KML file, which is a file that's got a bunch of polygons in it that represent neighborhoods in Vancouver. And we're going to use one of those neighborhoods to do a query back to the Oracle database and pick out some address points that are in that database table. So let's download that Vancouver data first of all. So click on the neighborhoods, and I do that successfully. Why is that not working for me? There we go. Got a couple of copies of that now, probably. Oh, and I've opened Google Earth to have a look at that instead. So too many clicks, too impatient to wait for this thing, but that's okay. Google Earth is just as good as a way of looking at this data and any others, if I can get rid of all these adverts and whatnot. Yeah, so there's the Vancouver neighborhoods, that the data that we've got in there in that view of the data. So we're going to pick one of those and do a spatial query back to our database. So another way of looking at that data would be to right-click on that KML file, or actually, sorry, I should say, pop open the data inspector and drag that KML file onto Data Inspector. And there's our different Vancouver neighborhoods, and the main thing is that somewhere in here we've got a neighborhood name that tells us what neighborhood we're going to be working with there. Okay, so that's the Vancouver neighborhoods. And then we're also going to be working with some address points. Now, KML data is always in lat long 84. And when you're doing spatial queries with FME, whether it's using something like the FeatureReader, or you're doing a point on area overlayer, or using something like the Spatial Filter Transformer, you have to line up the data. And part of that is ensuring that it's all got the same, within the same coordinate system that you're working with. So we're going to make sure that we have that same coordinate system. So let's start in FME Workbench. And we can drag that KML file onto our Workbench to open up the reader there. And don't think we need to change any of the complex parameters there, and just click on OK. And what do we actually want to read here? We can unselect all these and just choose the neighborhoods. We don't want all those feature classes to be read. Okay, and let's just check that we're reading the correct data by running that to a data inspector. There we go. There's our Vancouver neighborhoods projected properly into the Vancouver area. So that's a good start. All right, so first step is we're going to reproject that data into UTM-83, which matches the data that we're going to read from the postal addresses. If you're just doing a simple projection, like in this case here, you can use the reprojector. If you want to do more complex reprojections, you can use the CSMap reprojector that has more options on choosing the grid shifts and so on that you need to use. I'm just going to use the reprojector here. Red source coordinate system is read from the feature. So in most cases, if you're reading spatial data in FME, FME will also read in successfully the spatial reference that that data has, and so that's what we're assuming FME is doing correctly. And then I'm going to write out to UTM 8310. So that's in metric coordinate system. Okay, and then what we're going to do is just to thin down the query, we're going to add a tester in here, step 3. And we're just going to filter out all the neighborhoods, and we're going to choose using the neighborhood name. We're going to have a look at the neighborhood called Fairview. It doesn't matter which neighborhood you choose in there. And again, as you're working through these things, it's not a bad idea to tack on a couple of data inspectors and run them to make sure you're getting the results that you want as you go. So you can see there, this is the Fairview neighborhood that we've successfully selected there. So we're just doing a query with one feature. Okay, so now we're going to add the FeatureReader on step 4 here. And there's a whole bunch of interesting parameters that we can play around with on the FeatureReader. Okay, so the first one is the format that we're going to work with. So again, that's Oracle Spatial. In this case, we're going to choose the Oracle Database Training. And again, you can look at some of the parameters in here. Do you want to remove the table qualifiers and so on? And then we're going to choose which feature types or tables we want to read in this Oracle Spatial table. So we'll click on the table list. And again, if you had a large number of tables, you could use the filter here. Filter down the list of tables if you want to. And we're going to read in the postal address table. Okay, so this is now where we can start to play around with some of the query parameters that the FeatureReader offers us. So what you can do here is you can put in a where clause. So this where clause applies to all of the tables you're reading. So FeatureReader is not restricted to reading just one table at a time. We could read postal addresses and address points at the same time if you wanted to. So we would have 2 tables listed here. We could apply a where clause, but just be aware that the where clause is applied to both of those tables. So if the attributes don't line up, then that's not going to work very well for you. Then we can apply a spatial filter. So if you want to read all the data, don't apply a spatial filter. If you do want to read the data, then you can choose which spatial filter you're going to apply. So we're going to use an intersect. So this is point data, so basically any point that lies on the boundary or within the area of interest, we're going to pick that up. If you're doing point on line spatial queries, they can be more complicated, and so you can see all of these different types of spatial predicate that you can apply to the FeatureReader for doing that spatial query. Now, actually, what FME, in most cases, what FME does when it's doing a spatial query to a database or to any other reader that you're reading from with spatial data is it actually does a minimum bounding envelope query to the database and then uses some of the FME spatial filters to filter out the data based on the actual query that you've got here. Oracle actually is an exception for that, where we do, I believe, send back the full polygon to the database, and the database does the work for us in terms of the full spatial query. So that's good there. You can choose what kind of output ports you're going to get, one per feature type. You can get a single output port, which is kind of, we call that a generic output port. So that's good to look at sometimes. We're going to use one output port per feature type. We've only got one feature type or table that we're reading, so we're just going to get the postal address output port. Just going back to the table here. We've also, at the bottom here, got attribute and geometry handling. So how and what kind of attribute accumulation and merging are you going to do on the data? So where do the attributes come from? So in this case, we're firing off a query to the database using a polygon that's read from the KML file. And we're not interested in any of the attributes that come from the KML file, basically. So we're going to throw away the KML data and just read in the data or the attributes from the postal addresses in the database. If you want to keep some of the attributes from the initiator feature, then you can do that here, merge initiator and result attributes. If you want to add a prefix similar to what we were showing in the database joiner, you can do that there, add a prefix and so on. Similarly for geometry, where does the geometry come from? So we've got an initiator feature, which is a bounding polygon that we're using for the query. We probably don't want to keep that on every feature that is returned back from that spatial query. What we want is to keep the geometry from the result features. And so we can do that here, and that's the default behavior, which is usually the most sensible behavior. Okay. In the next step, we're going to add a where clause in there, but for now, let's just see what that looks like. I'm going to add a bunch of inspectors in there and then just run that and see what result we get. Okay, and so the result is the initiator polygon that we've got there and all the address points that we've got from the Vancouver Open Data website. Thanks a lot to the City of Vancouver for making that data available, I guess. Okay, and so some of the output here can be the initiator feature. Normally we would not be too bothered about keeping that. The results coming out from the postal address table coming out here based on that spatial query. We also get a special feature coming out of the FeatureReader, which is called the schema feature. We can have a look at that here. That schema feature basically tells us what the schema of that data that we've just read looks like. And that is done through these complicated list attributes here. We're not going to cover that today. There's a whole article on working with schemas in FME that covers this information, but you can see here that it's describing the structure of that postal address table. It's got the name of the attribute, the type of the data type of that attribute, and so on. That's a whole list of the 10 or so attributes that sit on or that come from that postal address table. So that can be useful when you're building more complicated workflows in FME for defining how you're going to write that data out in the destination side. Okay, so we could then write that out to an Oracle spatial table if you want to do that. We can throw in a where clause. I mentioned that. So going back in here, so that where clause is any where statement that your database supports. So remember, if you're using any SQL in any of these transformers, that SQL has to conform to the particular database that you're working with. So there are slight variants between the different SQL that these databases support, and you have to do that, make sure they match. And so we're going to say where the status is not like retired. And you notice there I picked the attribute from the postal address table, and that popped it into the SQL editor here. And click on OK. And let's rerun that. And so previously we had, going back to my workspace, I think we had about 1,400 features that we read, and then the where clause has narrowed that down a little bit more specifically to about 1,200 and something features. And so those are the address points that have not been retired from the address database. We've inspected the results. So there's a little adage here that we can follow wherever possible. The webinar that Tia mentioned earlier on yesterday that is going to follow up from this training, I think on the 24th of October, is it? That webinar is called Let the Database Do the Work. So wherever you can in FME's land, what we would recommend is that you throw the query back to the database rather than having it done in memory in FME. And so we're doing that here in the feature reader. We're reading an area from somewhere, throwing that to the feature reader to do a spatial query. FME is doing as much as letting the database do as much of that spatial query as possible. We're also throwing a where clause back to the database so that we only get returned the data that we actually want, rather than having FME read all the data from that database table and then filter it out in FME. So picture what that would look like if we didn't have a feature reader in FME. What we would have is we'd have an Oracle reader. And that Oracle reader would be reading from the postal address database table. And we'd read all those address points, and then we'd have to do some kind of a spatial query. So we could possibly use the point on area overlayer transformer. So that's the points. This is the area from our tester, so we'll just take that one area. And so now we've read all the postal address points. We're now filtering them in a spatial context. And then if we wanted to thin out those points that were not retired, then we would have to add in a tester here to filter those points out. And so in this case, if this was a very large table for the entire Vancouver region or Metro Vancouver, you can see we'd be reading a lot of data very redundantly, only to thin it out later on. And the feature reader does all of that through a query to the spatial database. So a good way to let the database do the work there using the feature reader. So we've covered the feature reader, reading data from a database or actually any other format in FME, allowing you to do possibly spatial queries. And those spatial queries will work on data that is not spatially indexed or is from a format where they don't natively support spatial queries. FME will figure that out for you. If it is spatial database, then FME will try and do the query back to the database. So we're going to move on to tools that allow you to do more complex queries to your database, and that's going to be the SQLExecutor. And then we're going to also look at the InlineQuerier. And we'll wrap up the morning with a thing called the FeatureWriter. So that's a lot of work, and stick with us because the FeatureWriter exercise actually covers pretty well everything that Tia and I have covered from yesterday and today. So that's a great exercise to wrap up the day. I should also mention that if you do have to leave us early, at the very end of my slides here, we always appreciate your feedback. So before the end of the day, if you can go to FMELY training feedback and fill in the survey there about the training, what other things you'd like to see in training, that would be great as well. We'll come back to that a little later in the day. Remember that we are working with the Oracle database connection that you created yesterday, the Oracle training databases. As in this last exercise you did, many of the exercises are referring to PostGIS, and so you actually can still do that if you want to run the exercise with the PostGIS database. But we're trying to focus on Oracle today, so we've made that Oracle database available to you. So, mastering spatial databases, we're going to look at SQLExecutor and SQLCreator transformers. So, there's quite a few places where you can throw a SQL statement back to the database within FME. Those are on SQL statements that you can set before or after you read or write data. So in the navigator, when you access a database reader or a database writer, under the advanced parameters, you see two parameters that are SQL to run before read or SQL to run after read. If you're working on a writer, it would be SQL to run before write and SQL to run after write. And so these two SQL statements here, if you put them in, will be run before FME actually starts running the workspace. And so it's a good place to set up tables, or if it's SQL to run after, you can build indexes and so on after all the readers or writers have shut down. FME is just about to close. It will fire off those SQL commands for you. So that's one place that you can send off SQL. Another place that you can send off SQL is on a where or SQL select statement on most of the databases that we support on the feature type itself. So on the feature type parameters on a database reader, you will see a where clause or a select statement. So the where clause is very similar to what we were doing just now. So we could refine the query and let the database do the work. So if we were reading from the postal address, the where clause could be where the status is not retired. If you throw in a SQL select statement here, what actually happens is FME replaces the SQL query that it would have done just through the reader with whatever you want to do here. And so you can do complex database joins within here. And as you read the postal address data, you can do some other join to other tables and add that data in as well along with the postal address data. So that's another place where you can send a more arbitrary SQL select statement to do a query back to the database. And that does have to be a query that's going to return something, a select, rather than something that would be a database operation like creating a table, truncating a table, and so on. And then we have a couple of other transformers, the ones that are SQL-related transformers. We did some simple SQL query in the FeatureReader. The SQLCreator and SQLExecutor allow you to do more complex queries operations, SQL operations on your database within the workflow. So your SQL statements might be used to create, drop, or modify or truncate database tables in your workflow. We had a good question yesterday. When we were trying to overcome that glitch of not having the correct tables loaded, we wrote new tables for you, and then we suggested you do a drop and create. And somebody said, well, does that drop and create include, when you drop that table, is it cascading the constraints? And the answer is no, it's not. So on the database writers, when you drop a table, it doesn't cascade constraints. So if you need to cascade constraints, if there's join keys and other things associated, you might do that within the SQLExecutor or SQLCreator using your own SQL. You can do more complicated database joins, add indexes and spatial indexes, or drop indexes or spatial indexes, attribute indexes. That's great when you are writing to a database, actually. It's not a bad habit to get into, because most databases, I think, will rebuild the index for every commit. And so if you have a spatial index or an attribute index, every commit that you make, it'll rebuild that index. And so that could be a lot of operations that you don't really need to do. So if you drop the indices first before you start writing, write all your data, and then rebuild the indices in one go at the end, that's a really good thing to do. So there's two variants of these transformers. The SQLExecutor requires a feature, an initiator feature, to trigger the query that you've built in your SQLExecutor. The SQLCreator transformer just triggers when FME starts. And so this is a good way of sequencing workflows and starting workflows from a query. And there's also some interesting things about sequencing the whole workflow. So these creator type transformers can be ordered just by the naming convention you use on the SQLCreator. I'll try and touch on that in a little bit. Both of these transformers and a lot of the other places where you can add SQL have a SQL editor that you can use. We've already been using that. And so when you're building a SQL statement, click on the ellipsis there, it'll pop up the SQL editor, and it's got a bunch of things that you can do. One is to look at the list of database tables that you're trying to access. You can play around with those database tables. If you expand on them, it'll give you a list of all the attributes in that table. And there is also an ability here to run or test your query or whatever SQL statement that you're sending to the database using this run key. Just be a bit cautious there, because it does execute that operation. So if you've got an operation that does a table delete, it'll actually do that table delete. And I've got a little example here of places where you might use that. So let me just grab that. One second, I should have had that ready to go earlier on. So this is actually a workspace that somebody will use in the webinar that we're going to give on this stuff later on. There we go. So this is just a workflow that's got a bunch of different queries in it. But here you can see we've got a bunch of SQL creators that are currently disabled, but would allow us to play around with some of the tables. So here I've got a SQL creator where we've built a SQL query that will drop a whole bunch of database tables before we start writing. And if I actually click the run button here, it'll execute that drop table command. So if you're actually doing some testing in your database and you want to execute some simple queries without opening up your database manager, you can actually set those up in here. And you can see I've got a drop table with the cascade constraints, so we're dropping any joins that might be associated with that particular operation. Got another one that's, instead of dropping the tables, is just doing some truncates, and we're altering the table, disabling the constraints and so on. So fairly reasonably, well, I guess now for Tia, very simple SQL after she's taken her midterm. And so these really are just SQL creators that I've got in here that I can either choose to run when I run the workspace just by enabling them, or I can just choose to just go into the properties of that SQLExecutor and run that to create the tables that I've got in here. So lots of options on using the SQL creators or the SQLExecutor transformers. If you do the run, hopefully you get a success there, and it'll tell you what you've done. There's also, if you right-click on a database table, there's some script as tools in the SQL editor that you can use. Probably the most common one you'll use is script as select, so it'll give you a starting point for a select statement. So I can have a quick look at that in that workbench I had up earlier. So if we go into the SQL editor here, we can see the list of tables. Yep, oh, that's a complicated list there. Let's say I pick on that table, just going to add a new line here, and then right-click on that table. You can see I've got a script as select, script as drop. So if I click on that script as drop, it's just going to throw in the starting point for your SQL. So if you're not very strong in SQL like I am, best to steal an example and then modify it. So that's a good way to do that. Okay. So let's start on a little exercise that gets us flexing our muscles with SQLExecutor doing a join to a database table. So back in our main document here, using SQLExecutor to do a SQL join. So we're going to use SQLExecutor to join records from the database table and relate that to the source features, which we're going to read from a GML file. We're going to be working with the postal addresses. We're reading a GML file that is the location of the fire halls within the area of the city of Vancouver, and we're going to try and add the address of that fire hall to that data. Again, kind of a denormalizing exercise. At the bottom here, we've got a couple of examples of SQL queries that we can experiment with. These are PostGIS queries, but we're going to try and modify them for our Oracle database. I just mentioned that most of the exercises that Tia and I have run through do have the final workspace up there. So if you get a bit lost today, you can download the final workspace and just walk through the example, or you can choose to run the example. So I'm going to download that GML data file. There it is. It's come out as a zip file there, and I'm going to leave it as that. Okay, so let's have a look at that firehall's GML file. So what can we do? We can open up the data inspector. And for those of you that didn't know, FME is quite happy to read data from a zip file. You just have to tell it what format you've got in there. It's GML. And we can click OK, and FME should happily unzip that data and pop it up on the screen. And there is our firehall information overlaid on our Stammen map background data. Okay, and we're going to try and do a join to the address database. We've already had a look at the postal address table in Oracle, but we can do that again if you want. And if you want to overlay it on the existing data in Data Inspector, you can just use the Add Data Set to the current view instead of just adding a clean data set, which will give you a second view up here. And so that will be an Oracle connection, Spatial, connecting to our Oracle training database, popping up the parameters to get the table list, and choosing the postal addresses in here. And we should get all that data popped up as well. Hard to see those fire halls within that mishmash of data. So remember, in Data Inspector, you've got all the display control at your fingertips. It is transitory, so it'll change every time you play around with this. But if you want the fire halls to be fire hall red, you can do that, and then you can make the points a little bit bigger so they stand out a little bit more. And you can start to see the fire halls a little bit more clearly. If it's areas and things you're playing around with, you can drag that up so it sits on top so that data stands out a little bit better. So you can play around with the display characteristics a little bit just to give you a better idea of what the data looks like. If you reload this data, you have to do all of that again. Okay, where are we? We're looking at postal address data, and so we're going to be using the address field to match to the property address in the GML file. So there's not really an ID key for doing the join here, so sometimes that's a little more risky to do. And so now we're going to set up the SQLExecutor. So back to our workbench. Going to start off by dragging that GML zip file onto my workspace canvas. Tell it that it is GML. And that should do it. I should get a firehall's object there. If you want to test that it's reading that properly, remember you can just add an inspector there. And then I'm going to drop down the SQLExecutor transformer. And there we're going to start to configure that SQLExecutor. I'm going to say what format I want to work with. So that's going to be Oracle. Going to connect to the training database, and then we're going to build that SQL query. And we're going to start off with the postal address table. So this is where we could say script as select to give us a bit of a starting point here. So we're going to say select everything from the postal address, and then I'm just going to add a bit more to that. It's at the bottom of the page here in my view. We're just going to add the where clause. So where, and you can have a multi-line view of this if you want to. And then we can choose which attribute we're going to use on the where. So where the postal address is equal, and now we're going to add a join to an attribute value that's coming from the initiator feature. So I can go down to the FME feature attributes. So these are the attributes that are on the initiator feature coming into my SQLExecutor. So those are the attributes that are on my firehall's GML file, and I'm going to say where the value is address. So this is going to be set every time. And the tricky part in all this SQL is to make sure that you've got the quotes in the right places. So I do need to do a single quote around that at value there, because it is going to be a string value when it's returned. So what FME is going to do is going to substitute the actual address value from the address attribute on the incoming features or the initiator features. You can test your string there. If you do include a global value or an FME attribute, then you can't actually do that run in there, so that's why you get that little warning message. Okay. Again, at the bottom, there's a whole bunch of parameters here where you can choose where the attributes are coming from. So whether you want to combine the attributes or keep both the initiator and the result attributes. So we want to keep them both. So I'm going to keep the initiator attributes. And if there's a conflict of attribute names, then the initiator attribute will win. And also, where do we want the geometry to come from? Do we want it to come from the initiator attribute, which is the firehalls, or do we want them to come from the address points that we're reading in? So we're just going to keep the firehall geometry there. And then pop on the data inspectors and run that. Okay, and so there, what we would hope to see is on our data inspector, the result features. We would hope to see a combination of the GML attributes that came in, whether this fire station's got a ladder or not. That's always useful in a fire station, I understand, and whether we've joined successfully to the address database where the postal addresses and so on came from. Okay, hopefully everybody got that. Now, where's my workspace? Really, I would call this a merge. We're not really doing a database join here. What we're doing in this particular example is we're reading some data, in this case GML, from the firehalls table, and we're using those as initiator features onto the SQLExecutor. We're triggering a query to the SQL to get the right data back that meets the where criteria that we've got here. And we're merging those attributes or those records onto the existing, let's move that down, onto the existing firehall features that we've already read. If we want to, we can expand this SQL to be more comprehensive SQL join. So we can actually do a SQL join in here. So let's do that. We're going to add a SQL join where we're going to join at the bottom here and include address points and postal addresses in here. Okay. So I'm going to leave that to you. Take this SQL here and modify it for your Oracle database to include the additional postal address information using the address ID. So we're doing an inner join on that. So there we're using the SQL to actually do a database join, let the database do the work, and then merging that joined information onto the initiator feature in the SQLExecutor. Okay, so in Oracle land, we don't have the have to put in the schema qualifier like the FME Data 2015. If you do have to put in a schema qualifier for the user, you could do that. That's what the FME part is here. So it's saying select from table A, which is going to be the postal address, all the attributes, and then from B, which will be the address points. We just want to pull back the civic number from postal address A, address points B, where the postal address is the address name, and to do the join on the two tables, A and B, the address IDs are the same. So there we are doing a bit more of a sophisticated join, inner join, I think that is, and then merging the results of that join with the initiator feature. So somebody asked, if I can move that out of the way. Somebody asked, how many times are we doing this query? And the answer is we're doing that query 8 times. Once for every firehole feature that comes in, we're firing off that query to the database and getting the result back. All right. Next up, we're going to have a quick look at another transformer, which we call the InlineQuerier. So the InlineQuerier Transformer is somewhat similar to the FeatureMerger in the sense that you've already read the database tables, and now what you need to do is do a join. Maybe not only database tables, it could be data from any other format that FME reads. So the difference between the InlineQuerier and the FeatureMerger transformer is that the InlineQuerier basically loads a temporary database, we use SQLite, and then allows you to run a wide range of SQL queries on those tables. So I've got a little workspace I'm going to download here as an example. Get rid of this old one. Okay, so we've got a data set where we're reading a disparate set of data here. We're reading from Esri shapefiles. We're reading property tax data from a spreadsheet from the Vancouver Open Data site. We've got the addresses that we've, in this case, stored in a file geodatabase, not our Oracle database. And we want to do some joins and calculations on that table. Now, you can do that, some of these with the FeatureMerger. And what you would find is that you're adding 2 or 3 feature mergers to do all these joins. So the way that the InlineQuerier works is that you can drop in the InlineQuerier onto your workspace, and you get a transformer that really doesn't have any input or output ports. And those input and output ports get added as you connect them up here. And then what you do is within the InlineQuerier, you can see the input table, and then you can define what the output is going to be. And then you can do a SQL query using the SQL editor based on the tables that you've added to the inputs. So looking at the one that we've already got in here, I've got the InlineQuerier. I'm loading into the InlineQuerier 3 tables from 3 different data sources that I've read in. And now what I can do is I've said, okay, these are the 3 tables I want to work with. And then I can do a whole set of different spatial queries. And you can see here some of them are just doing an average count. So we're doing a sort of a summary in here using SQL. So if you're very familiar with SQL, you can do some quite interesting things here. Here we're doing a nice join on different heritage data sites in Vancouver against their addresses and so on. And if you run that, you'll get a bunch of disparate results from the output. Some of them will just be single features. These are the ones that are doing the averaging and some of the calculations. And then here is the addresses and lot information from that more sophisticated join that we carried out on the heritage sites that we're reading in from the heritage site database table. So Sorry, that's coming in from an Excel spreadsheet, I think. No, shapefiles. Okay, so this InlineQuerier is a transformer similar to the FeatureMerger, where you've already read the data using a reader in FME or the FeatureReader or any of the other tools that we're looking at. Could be a SQLExecutor sitting in here somewhere. And then we load a temporary database, that's SQLite, and then that SQLite database, we can throw a bunch of queries back to that table, to the different tables that we've read in to work with that data. So just some points that we should make around the InlineQuerier. It's not an Oracle reader in its own right. We're focusing on Oracle data, so it allows you to read Oracle data from some other mechanism and throw that data into a temporary SQLite database. So the SQLite or the SQL queries that you build here have to conform to the SQLite SQL syntax that SQLite supports. Differences between this and the FeatureMerger is that the FeatureMerger only allows you to join two tables really together, whereas SQLQuerier allows you to do multiple queries. So if you have multiple tables you need join, then the SQLQuerier, the InlineQuerier might be a good alternative. What happens in the InlineQuerier in these queries, if we look at this more complicated query here, is that the query will read all the attributes. Now, in fact, what happens is that when you load in a table and you say, these are my attributes that are on that table, FME creates a special attribute on the feature that carries all the attributes. So really, the only attributes you need to preserve here are attributes that you're going to use in some of the joins in the SQL query you build across here. All the other attributes will be compressed and carried across through that query. So it does reduce the size of that temporary SQLite database. Similarly with geometries, if you're working with geometries, it's kind of harder to predict which geometry is going to come out first. And the geometry that will be attached to the feature is the geometry that appears on the first table in your select list here. And so in this case here, the geometry that comes out, if it does, will be any geometry on the property tax table. So that's a good thing to remember if you're doing joins that include features that do have a geometry on them. There's quite a lot more in this article around dealing with geometries, and so here you can see at the bottom a couple of example queries where we're just joining together the property tax information with the address data and just ordering the from statement here will dictate which of these two features return the geometry of the data that's carried across that SQLite database. So let's have a look at this little example here. We're just going to bring it up. I don't think we need to build this workspace today because the InlineQuerier isn't really directly related to our Oracle work today. But we'll have a look at that example using the InlineQuerier. So what we've got is an example workspace that is built using the FeatureMerger. And so that's the starting workspace that I've got here. If I double click on that, it'll open up. And so this is a typical workspace using the FeatureMerger that we were looking at earlier on today. And you can see that to do some of those more complicated joins, we've got two FeatureMergers that are stacked together here to create the results, and also statistics calculators to pull out the results of the averages and sums that we want on those data sets. And so if you find yourself building a workspace with multiple feature mergers, particularly feature mergers that sort of follow on from each other, maybe the InlineQuerier is a good example. And that example is in the complete option download here. And that's basically that workspace that we were looking at a little earlier on. So what we can do here is just add in a simple exercise here. We'll add in a query into the InlineQuerier to merge the property tax data with the address data table. And let's just make sure that the result includes the address point geometry in there. So what we're going to do is we don't need to connect up anything in here. You want to build a new output port, which we'll call tax address or something. And then in the SQL editor, you can use the address data and the property tax data. Maybe use the script as, if you feel like it, to help get started to join the property tax data to the address data. So there we are. That's what that query might look like. Select star from the address data A, property tax B, where the PID, property ID, I guess that stands for, is the same or matches. And again, because we're trying to pull the geometry from the address data here, we've got the address table as the first table in our select statement, so that that's the geometry FME is going to grab. So we're going to wrap up the day and our database training with the final transformer and exercise that we're going to do, which is talking about the FeatureWriter transformer in FME. So the FeatureWriter is a transformer that gives us an alternative way of writing out data to a database. So we're going to go to that article there. I think Tia's been chatting out those articles. And again, we've got a begin and final workspace example that we can work with here. On the FeatureWriter, we're going to start with the begin example. Okay, so in a conventional workflow, so most of the work that you did yesterday with the Oracle database, you were writing out to your Oracle database with an FME writer. And what that allows you to do is just to write to the data, but it doesn't really allow you much option on following up, on checking or building spatial indexes and so on after you've written. There are a couple of places on the writers, the SQL after write, which we looked at earlier on, that do allow you to write some SQL. But if you wanted to gather up some information, say you're tracking some bad data and doing some validation on your data, and you want to send somebody a report of bad features, you can't wrap that data up and email it off to somebody. So using the FeatureWriter transformer allows you to write the data and then do some follow-up after you have done the writing. So in the case of simple writing out, what you could do there is copy or move data after writing. So for example, if you're writing to a database, you could write to a database staging table, and then if everything works, you could do a copy with a SQLExecutor and move that data into the production table. That would be one option. Another option is if you wrote to a format like GeoPackage, you could wrap up that geo package and put it on an email and email it off to somebody. Or if you're writing to a database, you could just put together an email message to say, today we successfully wrote the data into the database. So if you're an administrator, that would be a way of tracking jobs that you've put on a schedule. You can also load the data onto an FTP site, S3, or other cloud kind of storage writing. Or you can do additional SQL calls after the writing. And the little exercise that we're going to do in a moment is we're going to write to the Oracle database and then use a SQLExecutor to give us the count of records that we actually wrote and compare that with the number of records that FME thought it wrote. And if there's a mismatch, then we could do something like send an email or whatever. Sometimes you have more complex workflows where you need to chain together different operations. You have an option in FME of using the workspace runner or the FME server job submitter if you're using FME server. Those allow you to chain together different workflows. You can change that paradigm slightly by using the FeatureWriter so that you can write some data and then within the same workflow trigger some other activity after that write is complete. So in some ways, the FeatureWriter gives you an alternative to using the workspace runner to chain together different jobs. Okay, so the one exercise that we're going to work through is somewhat of a classic CAD to GIS kind of workflow. We've got some CAD data that represents the water network in the Vancouver area from the City of Vancouver Open website. And we're going to write that data out to a Oracle database. And then we're going to look at the alternative ways of writing that data out to the geodatabase, to the Oracle database. And then we're going to see what we can do if we modify the workspace to use the FeatureWriter to do some follow-up operations on that data. So this exercise kind of does also cover a lot of the work that you've been looking at and doing yesterday and earlier this morning. Okay, so what we've got is the City of Vancouver data. So let me just open that up somewhere. I guess I've actually got to open that workspace. So what I've done is I've downloaded the FeatureWriter begin workspace. And then I'm going to click on the source data here, which is my AutoCAD file, and we can view that in Data Inspector. Quite a bit of data in this CAD file than we've been using in the past exercises. I'm just going to turn off the pressure zones and zoom in here a little bit. Try and zoom in. There we go. So we've got different entities in here. We've got the actual water lines of different diameters and so on. And we've got different point entities that represent the hydrants and valves on the Vancouver network. Those are the valves, the control valves there. And so we've got quite a complicated workflow here. This is the more complicated of the workspaces that we've worked with in the last couple of days. Typical database data loading exercise, in this case a CAD file, but the source data could be from anywhere else, any of the other formats that we support. So we got the control valves, the hydrants, different variations of the different water mains data. It's a classic case of FME data manipulation. We've got an attribute manager here that's doing some renaming. Typical of CAD data is that the data isn't always very well structured and doesn't always have the data that we need to write out. And so we're renaming, setting mandatory values. Here on the diameter, we've got a conditional value in the workspace here. So if the value in the CAD file is small, medium, large, then we set the values of the diameter to be those values. So we're setting some conditional things there as well. Same with the ancillary roles. We're setting Boolean types and so on. So quite a few operations in the different attribute managers that we've got as we read in the data to clean up the data and set appropriate values on the output data. For the water pipes, we've got a couple of transformers using the attribute value mapper that sets domain values. So if you're writing to a database that has coded domains, you can set those in the attribute value mapper. So we're setting the material attribute to be a coded domain from the descriptive value that's coming from that CAD file. And the same with the lining material, that's also going out to a coded domain. And then to wrap it all up, we're actually doing using the attribute validator transformer to do some attribute validation, just to make sure that the stuff we're writing out is relatively sensible, whether the attribute enabled is a Boolean data type, whether the diameter was in some sort of sensible range for diameters of pipes, whether the type is in a list here that matches the needs of the output data, and so on. So we're doing some attribute validation there. And in this case here, we're actually, although it says writing to a geodatabase, we're actually writing out to a geopackage, which is a OGC data structure based around SQLite. And so we could run that workflow if you want to. And it'll create a little geo package for us. We've got a data inspector set in there that's tracking some of the features that fail the data validation. That's these features coming down here, and we're looking at those in the data inspector just to see why those features failed. And they're going out, typically again of a validation report, they're going out to a separate table that somebody can look at to see which features failed the validation. Okay, so just to start off with, as a little bonus exercise, we've already done this today, is that this data is being written out to a geo package. So what I want you to do is to switch the writer here from GeoPackage to Oracle Spatial. So what I want you to do is add the Oracle Spatial writer and switch out these feature types to write out to that Oracle Spatial. And I think we've got a page here for the bonus exercise on how you can do that. So I'll just expand that a little bit so you can see it a bit better. Okay, so you're going to switch the GeoPackage writer with an Oracle writer, add the Oracle writer, switch the feature types to that new writer, and fill out some of these parameters on the feature type table definitions. Okay, I've started to work through some of the steps there. I added the Oracle writer. And then on the Oracle writer parameters, I set the ordinate ranges. Now, why would you do that? So these have popped up in the feature types. So the writer defaults are carried across to the feature types. And so you would set these minimum ranges or the ordinate ranges if you're creating the tables with FME. And FME, if you're writing to Oracle Spatial, will create the SDO geometry metadata records, which includes the coordinate system of the data, which in this case is UTM 83 zone 10 in meters. And if you're ever going to build a spatial index on this data, which we're not going to do as we actually write the data, but you could choose to build a spatial index down here in the parameters. But if you do build a spatial index, then really these ordinate ranges need to be set. Otherwise, the spatial index is only built within this range. And if you use the defaults, which are actually set for that long, then a lot of the data will not be indexed correctly. So if you're using FME to create your Oracle spatial data, you do need to keep an eye on the extents and tolerances that are set when FME creates the spatial table and the SDO geometry metadata along with that. Now, in many cases where what you're working with in Oracle is tables that already exist, and so very often you're going to be either truncating them or just adding to the end of tables and using an existing table. And so you don't really need to worry about that. But if you are using FME to create new tables, then I'm using the drop and create, then you do need to make sure that you work with those spatial references and set the right kind of values in there. We're going to turn off that data inspector. So there we are writing to that Oracle spatial table. I'm going to disable that so we don't keep that coming up. Okay, so that's the little bonus exercise, creating a new Oracle spatial table and switching from an existing writer to a new writer, which in this case was Oracle. Okay, it doesn't matter if you weren't able to complete that because we're going to carry on with this exercise using that same workflow. Okay, so our source data is that CAD file that's come from the city of Vancouver. And now we're going to start working through using the FeatureWriter. So we've had a look at the different transformers that we've got in that workflow, the attribute manager for setting up the attributes, the attribute validator for cleaning up some of the attributes. And now we're going to modify the workspace. So what we're going to do now is we're going to add a feature reader, and we're going to replace the AutoCAD reader with a FeatureReader transformer. All right, so here's the AutoCAD reader here, all these different feature types that we've got. And so what I'm going to do is I'm going to right-click on the navigator and I'm going to disable that writer. The other way you can do that in FME is you can click on any feature type, hover over a feature type, and you'll get the little toolbar there. And that second one there, the little database drum, will disable that reader. So I'm just disabling it. And then what I'm going to do is I'm going to add in a feature reader. And drag that up onto my canvas here. Now, I mentioned earlier on that there's different ways that you can initiate the feature reader. In this case here, I'm just going to trigger the read of the data using a creator. But it could be a SQL creator that we're running here with a query to pick out the features that we want to trigger the read of our AutoCAD data. It could be something like the directory path reader. So if you're going to read multiple CAD files, you could use the directory file path reader to read a list of files and then trigger the read of those files with the feature reader. And we're going to configure that feature reader to read from AutoCAD. Use the AutoCAD 3D object data reader, because that will bring in all the attributes as well. You need to go and point at that data set, which will be under, where will that be under? It'll be under the SQL Query FeatureReader folder. And I think what I actually have to do is I have to save that workspace first. Sorry about that. And then you'll be able to find that data in the FeatureReader, because we read that data from a template file, which kind of hides the source data a little bit for you. There it is. You should be able to find the City of Vancouver Water DWG file. And then what you can do is under the parameters for CAD data, if you're reading point data, most of you probably are not that familiar with CAD data, but when you read point data, those are often symbols, and you don't want to read the entire symbol. You just want to read the insertion points. So make sure you do toggle off explode blocks into entities. Otherwise, you get a little piece of data for every part of the symbology that we're reading. Feature types to read. So these will be all the layers in that AutoCAD file. It has to scan the AutoCAD file to find the layers. And we're going to read in the transmission mains, the hydrants, distribution mains, control valves, and the abandoned mains. All the rest should be pretty much the same. One feature type per output port. Attribute accumulation mode, just going to use the results, and we're going to use the result geometry to read that data in. And so what we'll see on the feature reader once the FME scan that data is an output port for all of those feature types that we selected, all the layers on that AutoCAD file. Okay, so now we can connect some of these guys up. We've got a guide here, and that's why I didn't delete the original reader, is so that we have some idea of where we're going to connect these guys up to. So the abandoned mains is going to go to that attribute manager there. Control valves will go up here somewhere. TPF's mains go to that attribute manager, distribution mains to that attribute manager, hydrants up here, transmission mains to this one here, matching pretty well the connections that we had on with the original reader. Okay. So then what we could do is we could test that, make sure the feature reader is working for us in the same way that the original reader did. So we can run that workflow. And if you're convinced that you're getting the same results that you got with the original reader, then what we can do is we can safely go in and delete that original reader, and there we have the feature reader replacing all those individual feature types on our canvas. Okay, attribute managers are gone red a little bit because there's a few attributes that didn't line up there. I think I'm just going to ignore that for now, but you might have to come back and address that a little later on. Okay, second part of our exercise is we're now going to replace the writer that we have on our workspace with the FeatureWriter. So we'll click on here and say add the FeatureWriter, typing onto my canvas. Here we go. And And then what we can do is we can start to connect these across here. Instead of doing that, what I'm actually going to do is I'm going to use the ability to import feature types from a reader or writer. So my format is going to be Oracle. So that's the Oracle Spatial that we're writing out to. Should be pretty familiar with this now. We're going to select the Oracle Training Database. Now, we've already been writing to the Oracle database, and so what we can do at the bottom here is we can import the feature types from that database. And so this is a very common way of configuring FME if the tables already exist. So we're going to import from dataset at the bottom here. Going to import from the Oracle that I've already been writing out to. And the tables I'm going to select are the water main, the water hydrants, control valves. I think that's it. And you can see there we've added those feature types there, and each feature type has the appropriate attributes stuck on it. So we pulled those attributes in from the Oracle database with their various data types. We could go and fix up, forgot to set the ordinate extents and so on, so we could fix those up. I'm not going to worry about that because we're not working with a large data set, and we're not at this point building a spatial index, but if we were, then we would probably want to fix up these ranges so that we created the right tables. But because we don't want to override the existing tables in the database, what I'm going to do is I am going to say drop and create. So we are going to create each of these tables from scratch. Okay. So there's our input. Got a weird one floating around in there. I don't know where that's come from, so I'm just going to delete that. And then again, what we can do is using the original reader as a guide, I'm just going to connect that up. So that's going to be the control valve. This one coming out of the attribute manager here is going to be the hydrant. And this one coming out of this attribute manager is going to be the water mains. Okay. And we've got all those user attributes there. I believe you can fiddle around with the ordering of the tables if it makes your workflow a little easier to read. So right down at the bottom here, you can move tables up and down. So I'm just going to select the water mains and say, I want that the last table in the list. And it should have reshuffled them so that makes the workspace a little easier to read. Okay, and then click on the original writer, and we can disable that writer. And then on the FeatureWriter, on the summary attribute, I'm going to send that off to the inspector, and that will give us a summary of the results that we've written out. Okay, so the FeatureWriter gives us a summary feature, so that's the only output that we get on the workspace canvas. And that summary feature tells us which feature types we wrote to. It's got this weird list here. So it's got the feature types we wrote and how many records we think we wrote to each of those feature types and the total number of features written overall. Now, one of the things, did we cover transactions yesterday a little bit? Not too much. So when you configure your Oracle writer, probably a little bit easier to see it up here. We've got the Oracle writer under the parameters. You can set the transaction intervals, which is how often you make a commit to the database. And because you're writing the data out in chunks, in this case chunks of 1,000, then if there's some kind of criteria on the database table that fails and so that feature is rejected, that whole transaction is rejected. So it's actually kind of hard in FME to know what particular record failed to write. And so that is a little bit of an issue that sometimes you have to work around when you're writing to databases with FME. So in this particular case here, if we had a record that failed to write, what we would get is a mismatch between the number of records that FME thought it wrote and the actual records that that did get written to that database table. And so what we're going to do is we're going to add a check to compare the number of records that FME thought it wrote with the actual number of records that it wrote out. And we're going to use these post-processing feature counts in here to do that. So we got one record coming out of the summary feature. And what I want to actually do is split that into 3 records, one for each of the different feature types that we've written. So the way we can do that is we've got this complicated list here. If you haven't worked with lists before in FME, they are kind of weird objects, but what we can do is we can say if I've got a feature with a list on it, I can break that up into 3 separate features. And to do that, I'm going to use the list exploder transformer. So just going to click on that link here, and I'm going to add list exploder. And it's going to say what list do you want to explode, and it's going to be the feature type list, which matches this one here. And so what it'll do is it'll actually get rid of this part of the name here, which is the feature type list, and just leave us with an attribute called name and count. Okay, so let's run that and see what that looks like on the output of the list exploder. There we go. So we've taken the single summary feature that came out of the FeatureWriter and split that into 3 separate records, each with a count on, you can see them here, for the number of features that FME thought it wrote out to that database. Okay, and so now what we're going to do is we're going to add a SQLExecutor to do a query to the database and ask it how many records I got in that database, and then we're going to do a test to see whether the number of rows we thought we wrote matches the number of rows we actually wrote to that database table. Okay, here we're illustrating it with OGC GeoPackage, but like in all our exercises, we're going to use the Oracle Spatial Oracle Reader to do that. So we're going to add in a SQLExecutor. And we're going to do a simple query to our Oracle. Doesn't matter whether it's Oracle Spatial or Oracle non-spatial reader in this case, connecting to our Oracle database. And we're going to add in a SQL statement. And that SQL statement will be against this database table, which will be based on an attribute name that we've got here, actually, which will be the table name. So that SQL will look like this one here up that we've got illustrated up here. So we're going to select the count from the table. We're going to give that a name as, you have to quote this, rows. You have to quote it, I think, because rows is probably a reserved word in Oracle. We could call it anything we wanted, actually. And I'm going to say that comes from the attribute name. So that attribute is the name of the table that we got from the summary record coming out of here. And so for each table that we wrote out, we're going to get a count of the data and see what the results are. Okay, so let's run that and see what we get. Uh-oh. Didn't like my SQL there. Somehow error occurred. Okay, so I got a little glitch there, probably in my SQL statement, which I'm probably not going to be able to figure out off the top of my head, but it's something to do with this count as rows. So I'm just going to get rid of that and see whether that will. Because I think rows is a reserved word. Says those tables are all uppercase.
Still comparing the table, isn't it?
Oh, I think it's because I've got the table qualifiers. I think you ran into this yesterday as well.
Mm-hmm.
Yeah, and so what it's doing is it's quoting both the table qualifier and the table name into a single attribute. There, look at that, so much happier. And so yeah, what it was doing there is in my SQL statement, I had the table qualifier as part of the name here, and it was stuffing that into a single quoted value. So FME dot table name just wasn't found in that SQL query. So here we have the counts for the number of features here. It's just returned us a weird looking attribute called count star. I think I could still go back in here and set count star as rows, which would give us a little bit more of a usable attribute. So it wasn't the reserved word there that was giving me grief, it was the table names. Okay, so now I should have an attribute on my features called rows. And so now what we can do is we could go back, sorry, in that SQLExecutor, what we should have done is we should say we want to keep initiator and result attributes. And so then what we can do is, just to wrap up, we can say we want to add a tester in here, and then that tester, we would compare the rows attribute with the count attribute. And that would give us the result that we need to see whether we've written the same number of rows as we have thought we wrote. Okay. So once you've cleared all that up, what you could do is you could go back to the original writer here and delete it from your workspace, so that now instead of having a traditional writer, you've got the FeatureWriter and doing some kind of post-processing on the data. There's more to this example if you want to have a look. So if you go and grab the other version of this workspace, which is the completed workspace that's at the top of this article here, somewhere, there it is. If I open that up, you can see other interesting things that we can do with FME in these workspaces that use a FeatureWriter. Here we're using that same SQLExecutor to test whether the number of rows matches that we pull together. Here we've got an example of actually triggering an email from the results of this. So the validated features coming out of our FeatureWriter, coming out of the validation report, come out of the summary, and we can then email a message to somebody using the emailer transformer after all the features were written that would tell us whether we had success. So if you were a database administrator and this was on a scheduled job, you would get an email of success or failure for your database loads. So there's lots of ideas that you could come up with to post-process your data after you've written it with the FeatureWriter. So that little example there covered quite a lot of ground on everything that we've been working with here in the last couple of days. We replaced a conventional reader with the FeatureReader here. We've used or shown here using Attribute Manager and Attribute Validator to clean up our data and validate it. We replaced a conventional writer with the FeatureWriter Transformer to work with our data. Did some post-processing on that using the SQLExecutor that we've been working with this morning to do different kinds of SQL operations, either recovering data from a database table or setting, doing operations like creating an index or dropping tables and so on. And a little quick illustration of other ideas you might have, like emailing out messages to people to show whether the data loaded successfully or not. Well, I think that pretty well wraps up our database training for the last couple of days. So thanks very much for sticking with us. Don't forget to bookmark this useful page here, the FME Oracle Troubleshooting Guide. That's a good place to go. The webinar that's coming up that Tia and Steve are going to run are going to talk a bit more about performance tuning in this kind of context. So that's part of our continuing education. So have a look for that webinar.
At the end of the month.
Thank you very much.
Thank you.